case, T1. Oh yes, grade 12, good morning, how are you today? This is Kamala, tutor and educator for mathematics and physical sciences online at Los Technology Pulupwani. Now to introduce to you to what we call as the sequences and the series in our video 3. Don't forget we have got video 1 and 2 about algebra. You can click on the link below, or you can reach us on our website below as well. Okay, so now in this topic, sequences and series, yes, we have what we need to know. Now we have this formula sheet here, and we're going to look at 1, 2, 3, 5, but we need to know how it comes about. Now these formulas here, which you see, 1, 2, 3, 4, and 5, they're not the only ones used in this topic here in your exam, and because of that, I have made for you a summary. So let us first study. After this introduction, we're going to look at different questions from different years, that is November and May, June, as you master the topic. Okay, so please don't be in a hurry, don't rush. I want you to pay attention and give me your ears and your time so that we can make this mathematics simple for you. This topic is a topic which is user-friendly and which is straightforward. All right, so number 1 here, this is the general term for the arithmetic. Number 2 is the sum of the first n terms of the arithmetic sequence series. And then number 3 is the general term for geometric sequence and series. And then number 4 is the sum of the first n terms of a geometric. And then number 5 is the sum to infinity of a geometric series. But how do they come about? I want you to pay attention, and I give you a better introduction so that we can do questions together with a better understanding. Let us proceed. Now this topic, it with the number patterns, and then look at the arithmetic sequences in grade 12 and geometric sequences as well, and then the arithmetic series and the geometric series. Okay, now remember that quadratic number pattern has got a general formula given by what? By Tn equals to an squared plus bn plus c, okay? Whereby this a, b, and the c, if you're going to calculate them, we are going to use our formulas, that is 2a equals to d2, and the 3a plus b equals to d1, and the a plus b plus c equals to t1. For example, if this terms of the quadratic number pattern T1, T2, T3, T4, and T5, now when you subtract T2 minus T1, you get the common difference D1. Then T3 minus T2, another difference here, and T4 minus T3, like this. If you continue and go ahead to subtract them, you're going to get what you call as the second constant difference. Now note that this differences also form what? A linear pattern, as we're going to see it shortly. Very, very important for us in our calculations. We are going to see ahead. Now, after getting this pattern like this, now you can go ahead to get your A, B, and the C using the formula I just showed you here. Like you're going to say 2A equals to D2. After getting your A, then you come here, you say 3A plus B equals to D1. After getting the B, then you come and say A plus B plus C equals to T1. That's what I have summarized it for you here. Now these formulas here, they don't give them to you on the formula sheet. Why? Because they want you to get them in your head as you practice. So now when you go to your exam, whether May, June, or November, they don't give you this formula sheet, these formulas here on the formula sheet. So please, as you do practice, they're going to get stuck in your head. Now note that The quadratic number patterns have a constant second difference d2, which you see here. Okay, so you're going to look at calculus on this quadratic number pattern, and I'm sure you'll be happy by the end of it. Now, another one here is what we call as the arithmetic sequences. Now, these are linear patterns with general formula Tn equals to A plus n minus 1 times d. Note that they have a constant difference d. Now, this constant difference for the arithmetic, to get it, we can use T2 minus T1, or we can use T3 minus T2, or we can use T4 minus T3. Okay, like in this case, T1 is A, our T2 is A plus D, our T3 is A plus 2D, our T4 is A plus 3D. So when you subtract any of these, like T3 minus T2, you get D. All of T2 minus T1, you get D, to which we call what? The common difference. Now, when you add the terms in arithmetic C, we generate what? Arithmetic series, okay? So if you say T1 plus T2, T3, and so on, what you get, we call it what? We call it an arithmetic series. Now, this series, the sum of these series, depending on the given information, remember that we are adding, depending on the given information. Like in this case, we can use the sum of the first n terms equals to n over 2 into 2a plus n minus 1 times d, as long as the question gives us the common difference and then the first term. Then we can get to know the number of those terms. Are we together? However, if the question gives us the first and the last term without a common difference, then we're going to use Sn equals to n over 2 into a, which is the first term, then plus the last term. This L is for the last. All right, and note we can find the Tn, also called it general term of arithmetic series, using any of the following formulas. Depending on the available information, I repeat, we can Tn in arithmetic using these formulas here. If we know the common difference and the first term, then we use Tn equals to A plus n minus 1 d. However, in some question, they can give us the sum of the n terms. If they give us the sum of the n terms, then we're going to use our Tn equals to Sn minus Sn minus 1. For example, if you're looking for T2, you're going to say S2 minus S1. If you're looking for T3, you're going to say S3 minus S2. If you are looking for T4, you're going to use the sum of the first 4 terms minus the sum of the first 3 terms. Also, if you're looking for T100, you're going to use what? S100 minus S99. All right. So please, guys, know that we can write the sum of arithmetic series using sigma notation. A very, very common question. Now, this sigma notation, the sum of the first n terms, we are going to get by first of all getting our Tn, in this case, which is called Tk, and then when we have that general term Tn or Tk, then we can add all those terms from k equals to 1 up to n. For example, the sum of the first 50 terms of this series of this 3k plus 2, now that's our Tk, which was our Tn. We put k equals to 1 and then we add until we get what? To term 50, okay, the last term. We're going to see examples here. And then also note that apart from arithmetic, we have what we call as the geometric sequence. Now, the terms in the geometric sequence have got a common ratio, and it is from the following formula. Okay, the following formula. This is a mistake here. I'll correct it now. We're saying that we're saying that what? We're saying that okay, this is supposed to be here. Supposed to be here. It should be I. here. Following. Okay. Now the Tn for the geometric is given by Tn equals to A r power n minus 1. Okay. And in that case, sequence has these terms here. T1 is A, T2 is A times R, T3 is AR squared, T4 is AR cubed, and the T5 is AR power 4. Now, if you divide the T2 by T1, you get a common ratio. Also, if you divide the T3 by T2, you also get a common ratio. Also, when you divide the T4 by T3, you also get a common ratio. And note that when we add the terms in a geometric sequence, we generate what? A geometric series. That is to say, when we say A plus AR plus AR and so on, until our last term, we form what? A geometric series. Okay, geometric series, because we are adding the terms, we can get the sum of the series using any of these formulas here. We can use Sn equals to A into 1 minus R power n divided by 1 minus common ratio. We use Sn equals to A into R power n minus 1 divided by R minus 1. Also note that we can write the geometric series using a sigma notation, like we're going to see in the examples. We can send the examples here. That is Sn equals to T cap equals 1 up to n. Like for example, S7 of this one here, it's going to be summation from k equals to 1 up to 7 over 3 into 2 power k. We're going to see examples, don't worry. Then from here, please note that the geometric series will converge to give us the sum to infinity if it has a common ratio between -1 and not bigger than what? Not bigger than 1. So our sum to infinity equals to A over minus common ratio, such that our common ratio lies between what? Between -1 and less than 1. All right. Now, with this introduction, let's look at the questions as we proceed. Oh yeah, now with that introduction, let us look at the questions. As we do the questions, remember what we have just discussed, okay? So we are starting with the 2025 May. By the way, 2025 November, I have the memo for this question. You can click on the link below to watch question 2. That's why I'm skipping it. So this is now 2025 question 2. They say here, given the arithmetic series 5 plus 7 plus 9 plus many until 93, determine the general term of the series Tn in the form Tn equals to Pn plus Q. Okay, so here now, this is what they have given us here. They have given us the set is arithmetic. So the moment they say it is arithmetic, what comes in your mind now means we have what? Common difference, which is a constant, that is 7 minus 5, that is a 2. 9 minus 7, that's a 2 here. Now our Tn for arithmetic, we said our Tn equals to A plus n minus times what? Times d, okay? So in this case, what's our first term here? It is 5, ne? 5, then plus our n minus 1. What about our common difference? It is the 2, so times 2 here. So it gives us 5 plus what? When you multiply 2 times n, get 2n. 2 times -2, you get -2. So the answer becomes what? Therefore, our Tn equals to what? Our Tn equals to 2n. 2n. What is 5 minus 2? It's positive 3. So that's our answer here. It is 2n plus 3. Then they say here that the given series represent the number of kilometers that an athlete ran each week in preparation for the ultra marathon. Okay. Then, so this one shows us what? The number of kilometers. The number of kilometers. And they say that the athlete ran 93 kilometers in the last week. So this is our last term here, the 93, okay? And then they say, how long in weeks was the training program? So we're going to look for the n for this 93, so that we have our Tn now. Now that we have our Tn, as you can see, it is the 2n plus 3, okay? So because we have the Tn as 93, that means we're going to look for the n when Tn is 93. So to get the number of weeks, here, so I'm going to say that 2n plus 3 equals to what? Equals 93. Okay, so now 93 minus 3, it gives us 90. So 90 divided by 2, it gives us n as 45. So for that matter, it means that how many weeks were they? We have 45 weeks. So it is 45 weeks. Then they say the athlete used this opportunity to raise funds for her high school. The community sponsored her 10 rands for each kilometer run during the training program. Calculate the total amount that the athlete raised for the school. So to get our total amount, we need to know the number of kilometers. We need to know what? The number of kilometers. So because there are 45 weeks, and this one is arithmetic, you're going to sum up all the kilometers for the 45 weeks. Ne? And when you get this, when you get this number of kilometers, multiply them by the money for each kilometer, they're going to give us what they want now that was raised. So here, what do we do now? I'm going to say that because I have the first and last term, the first term is 5, ne? Last 93 here, I can say that my Sn, okay, my Sn, like we said, we have got two options, ne? We said you can use the what? You can use the first term and then plus the last term, ne? Okay. So in this case, I'm going to set S of 45 is going to be the 45 here divided by 2. Now the first term there, it is what is 5, ne? It is 5. Last time is 93. I'm going to say 5 plus 93. I'm going to say 5 plus 93 plus 93. And then here, calculators, what do you get? Calculators, what do you get? Here I'm getting 2205 kilometers. It is 2205 kilometers. 2205 kilometers. You see, at the ran. So to get the total amount of money, okay, you're going to multiply the 10 rands for each kilometer times these kilometers, that is 225. So she got how much money? She got this much money, that is 22050 rands, okay? That's the money collected. Hope we are together. And then they say here that the general term of the geometric sequence is Tn equals to n plus 2. Write down the first term. So if this is our Tn here, just put n equals to 1. Ne? So our first term T1 equals to 2 power 1 plus what? 1 plus 2, which give us 2 power, that is 8. That is 8. Then they say here, they want a common ratio. Because I say it is geometric, we get a common ratio. Or you can use T3. So the T2 here is 2 power 2 plus 2. Okay. And then divide by T1, which is 2 power 1 plus 2. So we have 2 power 4 divided by 2 power 3, which give us a 2 as our common ratio. They say calculate T20 and write answer in powers of 4. Okay. So because we have the Tn, we are going to say that our T20, because we know the Tn, the Tn is given by what? By 2 power n plus 2. Okay, so therefore the T20 is going to be 2 power 20 plus 2. But because they want it in powers of 4, I'm going to say, what is 20 plus 2? That's 22. Now 22, the same as saying it, power 2, and then power 11. Now what is 2 power? 2 power, that is the 4. So the answer which they want is what? The T20 in the powers of 4. It's going to be 4. The power 11, that's our answer there. Then they say calculate the sum to infinity, 1 over Tn, 1 over Tn. So because we have our Tn, we say 1 over Tn. Okay, we're going to have it as in the following manner. We're looking for sum to infinity. So our T1 was 8. So you have here 1 over 8. That's our T1. Case now, our T1 is 1 over 8. Okay. And then our T2 is going to be 1 over. Now 2 plus 2. Okay, let's deduct 1 over 2 power 4. Which is 1 over 16. 1 over 16. Okay. Let us get our common ratio. How do you find the common ratio? It is T2 divided by T1. It is T2 divided by what? By T1. So we're going to say 16 divided by what? By 1 over 8. Okay. Which gave us 1 over 16 multiplied by 8 over 1. Same as saying 1 over 2. So the common ratio is 1 over 2. Now the sum to infinity is given by what? Well, the formula says sum to infinity. We have said that the sum to infinity is given by S infinity equals the first term divided by 1 minus common ratio. So the first term there, it is 1 over 8. Okay, 1 over 8. What about common ratio? It's 1 over 2. So we're going to have 1 over 8 divided by, now 1 minus 1 over 2 is 1 over 2. Okay, 1 over 2 here. And so for that matter, it gives us what? We're going to get 1 over 8 multiplied by what? 1 over 8 multiplied by 2 over 1, which gives us 1 over 4. So 1 over 4 is our sum to what? To infinity, for that summation of 1 over Tn until infinity. Are we together? Next question now. They say consider they're saying consider the first 21 terms of the sequence Tn equals 2 power n plus 2. Calculate the sum of the terms in this sequence that are not powers of 4. Alright, we don't want powers of 4. Okay, no problem. Let's get some space here. Where is this now? Okay, so then I want the sum of the terms that are powers of 4. Now, first of all, what do I see here? My Tn is this one. The Tn is what? It is 2 power n plus 2, right? Let us check the term which we have here. When we talk about T1, that is 2 power 3. We talk about 2, that is 2 power 4. We talk about T3, that is 2 power 5, okay. Talk about T4, that is 2 power 6. Talk about T5, that is 2 power 7, okay. And so talk about T20, that is 2 power 22. And then lastly, they said the 21 times, then 21. Then T21, that be 2 power 20 what? 23. Okay, so now the question is clear. We want the sum of the terms which are not powers of 4. So in other words, those terms with the odd powers here, like this one here, not a power of 4. And this one here is not a power of 4. Those terms with the odd powers are not powers of 4. And then last time is this one here. So now we need to know how many terms are here. Now from here, let us first get our common ratio. Our common ratio given by 2 power 5, okay. It gives us 2 power 2, which is the 4. That's our common ratio. But we know that for geometric, our Tn, I don't know how many times are there now, our Tn equals to a r power n minus 1. If I consider this one here, which is 2 power 23, it's going to be 2 power 23 equals to a, which is 2 power 3, times common ratio, which is the 4 power n minus 1. I need to know how many times are they that are not powers of 4. So here, this is 2 power 23 equals to, now if I divide by 2 power 3, if I divide by 2 power 3, I'm going to say that 2 power 23 divided by what? By 3 equals to 4 power n minus 1. So here, I'm left with the t power 20 equals to 4 power n minus 1. This is 20. So from here, I can see that 2 power 2 multiplied by 10, the same as saying t power 20, equals to 4 power n minus 1, okay? So this is the same as saying 4 power 10 equals to 4 power n minus 1. So because I have the same base, which is 4, from my exponents, like in our video 1, I can see that n equals to 10 plus 1, which is 11. So I get 11 here. So I'm going to look for the sum of the 11 terms out of these ones here, and those are the terms whose powers, which powers of 4. And being geometric, how do you find the sum of terms? The sum of the given terms for geometric, we said, but by now, what did we say? Anybody who remembers, what did we say? That our Sn for geometric, our Sn equals to into 1 power common ratio minus 1 divided by common ratio minus 1. So in this case, the sum of the first 11 terms, which are not powers of 4, going to be here. The first term is 2 power 3. Then in 2, common ratio, we say it is 4. Now these are 11 terms minus 1. Then divide by 4 minus 1. What do you get, calculators? Now you get what? Calculators. What do you get? When you get calculators, here I'm getting 111, 111, and then 84, and then 808. All right, that's what I have here. Thank you so much for watching. Catch you in our next video. Bye bye. Oh yeah, this is question 3. Question 3, 2025, May, June. They say, given the quadratic sequence 14, 9, 6, 5, show that the general term of this sequence is Tn equals to n squared minus 8n plus 21. Okay, in our explanations, we said that a quadratic sequence has a second constant difference. Ne? So in this case, let's find out. Let us find out now. So here, remember we have the 14. Okay. Then we have what? We have 9. And then we have 6. Okay. Then we have the 5. Ne? We have the 5 here. So, they said, subtracting. What's 9 minus 14? We get negative 5. Ne? Okay. Negative 5. And then 6 minus 9, we get negative 3. Okay. And then 5 minus 6, get negative 1. Now being quadratic, we continue. Okay. Then negative 3 minus 5, get positive 2. And then negative 1 minus 3, also positive 2. So this one is what we call, okay, this 2 here is our D2. And then the negative 5 is the D1. Negative 5 is what is D1. Okay. And then this is T1. T1 is 14. Now I have told you in the introduction that any quadratic is of the form Tn. Okay. Tn equals to what? Equals to an squared plus bn plus c, whereby we can find the a, b, and c using the formulas I showed you. Okay, we said that you can use to get our down here. We said that actually you can put them. You can always put them here, that you don't forget. The d2 is the same as 2a, so 2a equals to d2, and then 3a plus b equals to d1. 3a plus b equals to d1, and then a plus b plus c, a plus b plus c equals to t1. Okay, so now begin from down here. We are going to say our 2a equals to d2. What was our d2 here? You can see it is 2, right, guys? So divide by 2, our a becomes 1. After getting a, put the next one on top here now, this one. Then use 3a plus b equals to d1. Okay, 3a plus b equals to d1. But what is our d1 here? d1 is negative 5. Okay, but since we have the a, we say 3 times a, and then plus what? Then plus b equals to negative 5. Okay, so here now the 3 become negative, and so our b equals negative 5 minus 3. Negative 5 minus 3, which give us b as 8, negative 8. Ne? Okay. After getting the b, now to get our c, we use what? We use a plus b plus c equals to t1. Anybody who can see t1 here? It is 14. You guessed right. Then our b is negative 8. We're looking for the c. What about t1? It is 14. So 1 minus 8, that's negative 7. And then plus c equals to 14. Okay. And then our c equals 14 plus 7, which give us what? Which give us 21. After getting a, b, and c, you can now say therefore the tn equals to an, but a is 1, equals to 1n squared. What about our b? Negative 8, so minus 8n. What about our c? 21. That is our answer here, which they wanted here. I hope we are together. Proceed. Then here now, they say that two consecutive terms of the quadratic sequence have a difference of 33. Calculate the value of the larger term. I repeat, two consecutive terms of the quadratic sequence have a difference of 33. Calculate the value of the larger term. Okay, I'm talking about the difference. Okay, have a difference. Now, when it comes to quadratic patterns, note that we have the second difference. We have what? We have the second difference here, which is 2. And then we have the pattern of the first differences. This one here. We have what? A pattern of the first differences. Now this pattern has got a relation which is the quadratic pattern. Now what you see here as 14 is t1 for the quadratic pattern. Okay, it is t1. It is t1 for the, and then the 9 is t2. Okay, and then the 6 is t3. Okay, and then the 5 is the t4. Then in my numbering here, what you see as negative 5, the negative 5 is the t1 for the pattern of the past differences, and then the negative 3 is the t2, and then the negative 1 is the t3. I don't know if you see them properly. Now there is a relationship between the capital T's and the smaller t's here. That relation says, it says tn. It says what? Tn, that's for the smaller one now, to tn is equal to tn plus 1, let me use the right color, equals to tn plus 1, now the capital one, the real quadratic net, tn plus 1, and then minus what? Minus tn. For example, this t3 which you see here, the t3 equals to t3 okay, rather equals to t4 for the quadratic, to t4 equals to t4 for the quadratic, okay, and then minus t3. Okay, all right, now our task is to find that this is tn here. Now to get our tn, this one here, we see, okay, we're going to use our tn equals to a plus n minus 1 times d. Okay, but then our a in this case is not 14 but negative 5. I'm going to say here negative 5, okay? Then plus n minus 1. What about our common difference? Who can tell us the common difference here? Now the common difference here, it is what? The common difference is 2, the 2 here. Okay, so open brackets now. Our Tn comes here now. Our Tn, okay. Our Tn for the differences, ne? Our Tn is equal. Now it's going to be negative 5, ne? Okay. Now when you multiply the 2 times n, you get 2n. Then 2 times negative 1, negative 2. Okay, so what do we have here? We have our Tn equals to 2n minus 7 equals 2n minus 7. Are we together? Now the question is that this difference is what? It is 33. So meaning our Tn is going to be equal to what? To 33. So that we can find that n to be used. So here our 2n equals 33 plus 7, which gave us what? Which gives us the 40. Which gives us the 40. So when you divide it by 2, our n equals to 20. N equals to 20. Now the question was saying that which number is bigger? Now if I look at my relation here, it means that the Tn plus 1 is T21. Then the Tn is the T. So meaning from the quadratic, I have these two. I have the T n plus 1, which is T21, and then the Tn, the T20. When I subtract the 2, I get what? I get the 33. Okay, so the question was saying that which of these two, let us check it again. They said that here, calculate the value of the larger term. This two here, which one is larger? Is it T20 or T21? It is of course T21 because this answer is a positive. So you're going to find T21 over the original quadratic using this formula. So our answer will be T21, okay, it's going to be what? T21 T equals to 21 squared, okay, 21 squared, then minus 8n, but n is what? N is 21, right? N is 21, and then plus 21 here. What do you get, calculators? What do you get? Here I'm doing. So the answer is 294. The answer is 294. That's our answer. All right. Let us proceed. So here it is T21, which is 294. Now they say here that the value of m added to each term in the quadratic sequence determine the values of m for which only the term T1 and T7 of the quadratic sequence will have negative values. I repeat, the value of m is added to each term in the quadratic sequence. Determine the values of m for which the terms in T1 and T7 of the quadratic sequence will have negative values. Now, as we do this question, please don't forget that we're talking about a quadratic pattern. And if you look at our coefficient of n squared here, it is positive 1, right guys? Positive 1. So being this positive 1, I want you to bear in mind that then the shape for this quadratic, the shape would be like this. The shape would be like this, whereby it has a minimum and a what? And a maximum, okay? We have a minimum value here because of this one being a positive 1, né? And so, now this minimum is a turning point, né? Whereby that turning point, we can find it. We know it's given by what? By x. X equals to b over 2a, which would be, what is our b here? Negative 8, né? So minus of negative 8 divided by 2a, but our a is what? Our a is 1. So it gives us a 4. Meaning this turning point here, it happens when when the term is what? Term number 4. The term number. Okay, meaning at T4, that's why we have the minimum turning point for this quadratic. Now the question says that determine the values of m for which only the terms between, let's say between T1 and the T7 of the quadratic sequence will have negative values. So now if I check with my sequence here, if I put in T1, the T1 here, 1 squared, okay, minus 8 times 1 plus 21. What do we get here? The T7. If I put in the T7, then here it's gonna be 7 squared, okay, minus 8 times 7 plus 21. So what do you get here? Calculators. Here I'm getting 14. I'm getting 14 and 14 here. Meaning that if I may draw the line, if I may draw a line here, that's a horizontal line. This one, let's say this one here. Okay, this line here is passing through the 14. And that 14 is our what? Is our value here for this turning point. So this is 14. This is 14 here. This is 14. Okay. And then now this one here, the first part here, it corresponds to 1, then corresponds to 7. Meaning that if I like this, if I made like this, this one here, if I come down here, I'm gonna come down like this and down here like this. Okay, so this one corresponds to 1. Okay, that is T1. This is T what? T7. Now between, because they said between T1 and T7, which means we have to consider now the next value after T1. That's going to be T2. So if our 2 is somewhere, if this is our 2 here, and before the 7 is the 6. If this is 6 somewhere here, okay. Now by the symmetrical nature of the quadratic, the 2 and the 6 must have the same y value. Okay, they have the same y value here. We can find it if this is these are y values, okay. We can find it here. Here we got 14. Don't forget, here we got 14. Now if I put in 2 or 6 and I set t of 2, I'm gonna set 2 squared here minus 8 times 2, 21. Also I find the T6. If I find T6 here, that'll be 6 squared minus 8 times 6, okay, and then plus 21. What do you get, calculators? If you put in the 2 in the quadratic, what do you get? Now here I'm getting 9. I don't know what you get that side. I'm getting 9 for both of them. So this is 9 and this is 9 here. Okay, so this is 9 here. Now the question said that determine the value of m for which the only terms between t1 and t7 of the quadratic will have negative values. So meaning that this 9 is the value, all together. So for me to have a negative value after adding m, I'm gonna say 9 plus m should be negative, less than 0. Now that my m should be less than negative what? Negative 9. Are we together? And then, because I'm looking for negative values, now if I'm gonna use, remember that if I add anything to this, okay, you see the values here like 8, 7, and so on here. If I add any number to make it negative, and I'm adding a number between 9 and 14, that will be negative. But because I'm dealing with the negatives now, my answer is gonna be from negative 14. That's not my m. It's less, okay, or equals to m, but then less than negative. That's our answer here. I hope we are together, because if you add any number here between negative 9 and negative 14 to these other values which are less than the 9, you get a negative. That's how we do it. Let us. Oh yeah, this is November 2024, question 2. It says that the first term of an arithmetic series is 7. The common difference of this series is 5, and the series contains 20 terms. Calculate the sum of the series. Okay, so here they're giving us what? They're saying it is arithmetic. It is what? It is arithmetic. And being arithmetic, what do we know? We say it must be having a common difference, and because they say it is arithmetic, do we know? Now so far, this is our first term, so this is our A. Our A is 7, or you can call it T1. Then the common difference, that's our D. Our D is 5, okay? Our D is 5. And then the number of terms is 20. So 20 terms are the terms for this arithmetic series. We're looking for the sum of the series. So because there are 20 terms, looking for S20. And we said that for arithmetic series, if we don't know the last term, then we use Sn. So we use Sn. We use Sn equals to n over 2, open brackets, into 2a plus n minus 1 times the common difference. Okay, so now we're talking about S20. You're going to say 20 divided by 2, okay? Open brackets now, 2a, but our a is what? Our a is 7. 2 times 7, then plus 1. Now the n is the 20, so 20 minus 1 is 19, okay? Then the common difference is the 5, as you can see it here, it is 5. Okay, so You can get your answer. It's gonna be what? Calculators, what do you get here? Calculators, put everything the way you see it here in the brackets. Don't confuse the brackets. Okay. And so here, S20, I'm getting 1090. I'm getting 1090. Getting 1090. Get next. They say the original arithmetic series is extended to 75 terms. The sum of these 75 terms, okay, is 14,400. Okay. Then they say using sigma notation, write down an equation for the sum of the terms added. For the sum of the terms added. Okay. Let us find out now. Now, originally we know the sum of the first 20 terms is this 1090. Let us write what we have here. We have the sum of the first 20 terms, that is S what? The first 20 terms are given by what? We just got 10 what? 1090 altogether. And then, now the first 20 terms, when you extend them to 75, that sum of 75 terms is what? Of the 75 terms now is going to be the 14,400. It is 14,400, okay? So, then we want the sigma notation, okay, the equation for the sum of the terms added to the original series. Okay, now let us understand properly here. Because like I told you, please, we don't have to cram, né? If you cram, you crash. So, now originally, I was having the first 20 terms altogether, and then plus from the T21, T21 plus T22, okay, then plus T23, okay, until you reach 70 what? 75. Until you reach what? 75. Until you add T, until you add T70 what? 75. Okay. We add all these terms up to 75. What you get is the 14,400. 14,400. Okay. So now here, the S20 is this 1090. Okay. We're going to say 1090 here. That's S20. Then plus the summation, the sum of the terms from what? From n equals to 21 up to 75. You see the 75 here. Up to 75, okay? Of the nth term, which is Tn, okay? Should give us 1, 4, 4, 0, 0. Okay. Let us get our Tn now. Now, also being arithmetic, our Tn is given by the first term plus n minus 1 times common difference, which I hope you remember very well. Now, our first term here given to us, they gave us what? They gave us the first term as 7, and common difference is 5. We're going to say 7, it is 7 here, then plus, open brackets here, n minus 1 times a 5, okay? Now here, we're going to get 7 plus 5n plus 5n minus 5. So 7 minus 5 gives us what? It gives us 2. So our Tn is going to be 5n, okay, plus 2. 5n plus 2. So from this equation 1, then our answer is going to be now summation from n, okay, n equals to 21, n equals 21 up to 75. Now our Tn we have what? We have 5n plus 2, okay. Then we're going to subtract now the 14,400 minus 1090. What do you get? 14,400 minus 1090. Here I'm getting 13310. 13310. 13310. So answer here for that equation. Hope guys we are together. Don't cram, but understand. Let us continue. Then they say that the sequence of the first pattern is 1, 3, 5, okay. Then they say here that if T99 of 1 is 9632, T99. Now, guys, I showed you something here. Let me repeat this because I really want you to understand. Now, this is with the ones T1, okay, T1, then T2, and then T3. So this is T2 here, and then T3. Now this is quadratic, okay, and then T4. This is what? Quadratic, and T5, okay, and many more. This is the quadratic pattern. This is what? Quadratic pattern. But then when you subtract this T2, what you get, we call it the small T1 for the differences. When you subtract the T3 minus T2, then you get a small T2 for the differences. When you subtract the T4 minus T3, then you get the T3 for the smaller differences. Again, subtract T5 minus T4, you get T4 for the smaller differences. Now this pattern here also, it continues, okay. Now, what they gave us here, they gave us values of 1, 3, and 5. So what is here as our T1 is the 1. So this is 1 here. The T2 is a 3. The T3 is the 5. Being a quadratic, we go ahead and say that 3 minus 1, we get a 2. And 5 minus 3, we get a 2 here. So, now they say that, okay, now from our theory, if you remember, but we said that there is a relation between the small t and the capital T. And that relation says that our Tn for the small t is equal to the capital Tn plus 1, okay? And then minus what? Minus capital Tn. For example, in this question, we're talking about T99 and the T98. Okay, so because 98 is more than 99, I'm gonna say if I can get my T98, okay, I'm gonna equals to T99. That's now n plus 1. T99, okay, then minus T98, okay, minus what? T98. So from this pattern here, I can get my Tn. And without wasting time, my Tn, the small one, my Tn, the small one, is going to be a n plus n minus 1 times d. Okay, but this is small, this a which you see here now is this one which you see as 1. So I'm going to say this is 1 plus n minus 1 times d. But that d is now the 2 here, so times 2 here. So in other words, my small tn, my small t is going to be what? My small tn is going to be tn is equal to 1 plus 2n minus 2. So our tn is going to be the 2n. Now 1 minus 2 gives us minus 1. You see? So after getting that tn now, I'm going to find my T98 here. Okay? So my T98 is going to be T9. When I substitute now in here, it's going to be 2 multiplied by 98 minus 1, which gives us what? Calculators, what is T? 2 times 98 minus 1. What do you get there? Now here, I'm getting 195. I'm getting 195. Okay, so I'm gonna say here that 195. Okay, 195. Okay, 195 is equal. Now the T99 they gave us. Do you remember that? Let's find out here. The T99 here they gave us, it is what? It is this 99632. I'm gonna say here 963 and then 2. I'm looking for the T98. Okay, so minus T98. Okay, here then from my calculator I can say that T98 become positive this side, so positive 98, then equals to 96. Okay, equals 9632 minus 195. So what do you get calculator there? What do you get? So here I'm getting 9437. I'm getting 9437. That's our answer for this question. And then they continue to say on 2.2.2, if it is further given that our third term, that is T3, our third term is 32, then now find the Tn, the general term Tn. Okay, so guys, where I have T3 now, T3, I put 32. I put 32 here. So my T3 is 32. So now, when I have this difference as 2, then I can find the Tn which they want. Okay, so here we go. We said that on the formula sheet, they don't give you this formula, so you must keep it in your head. We said that n quadratic Tn is given by an squared, okay, an squared plus bn plus c, okay, and so our 2a equals to d2. D2 here is the 2, guys, I hope you see it, equals to 2, and so our a equals to 1. After getting A, we can get B because we know that our D1 is given by 3A plus B. 3A plus B is D1, which is the one here. So I'm going to say here that 3A, but now I know the A, it is 1. Then plus B equals what? Equals to 1. So my B is 1 minus 3, which is negative 2. After getting the A and the B, now because I don't know the T1, I will not use A plus B plus C. But because I know the T3, I'm going to use T3. But before that, I have my partial Tn as Tn equals to 1n squared because my A is 1. Then minus 2n because my B is 2 minus, then plus C. But let's say our T3 is what? Is 32. Here, 3 squared minus 2 times 3, and then plus C should give us 30 what? Should give us 32. So this is 9, okay, minus 6 plus C equals 32. Now when you say 32 minus 3, your C becomes 20 what? 29. And so the required Tn is going to be Tn equals to n squared, okay, n squared minus 2n and then plus what? Plus C. Minus 2n plus what? Plus C. That is, but this is 29, okay? So I'm going to say plus 29. Plus 29 here. Now that's our answer for the general term of the quadratic. Please don't cram, but do what? Understand. If you don't understand, you can inbox me on 0785 222041 or tomorrow to the college. Roster College Pulukwane. Yes, or you can meet us online by clicking on the link below and join our extra classes. So that's what we have here. Next question upon 24. Let's check it. That's right here. That is question 3, November. This one here. What does it say? It says that a circle with radius 6 is drawn. The second smaller circle is drawn through the center of the first circle and also touches the first circle internally, as shown in the diagram. A third smaller circle is drawn through the center of the second circle and touches the second circle internally. The process of drawing circles continues and forms a geometric pattern. I repeat, a circle with a radius of 6 centimeters is drawn. Okay, so let us go slow. Meaning, our first circle is this one here with radius 6. Okay, this one, which you see in red, the bigger circle. Now what I'm drawing here is diameter. Diameter. Radius is 6. Okay, and that's our first radius for the first circle. It is 6. Okay, it is 6. And then what do they do now? After the first radius, the first circle, they draw another circle passing through the center. You can see passing through the center. Then now that one has got this diameter here. Has got this diameter here. Okay, this diameter here. this one now. Now down which you see in blue, circle drawn, okay? Now the next circle drawn here, which you see in blue, its radius now is 6 divided by 2. So our next circle is 6 divided by 2, which gives us a 3. And then now the third circle, which I'm now drawing, okay, this is now green color here, is also passing through the center. But they all meet at this point here. So now if you divide the 3 by 2, radius over the third circle is going to be 2, which give us what? 1,5. So it is 1,5 centimeters. That's what they say, radius over the third circle. So it's going to be 1,5 centimeters. Okay, so that's our answer there. Okay, then next here they say that find the sum of the areas of the first 10 circles. Now, how do I find the area for the circle? Now, this they said some forms of geometricness. So you have got our T1, okay, and then T2, and then okay. Are we together? So now here now for the radii. This is for the radius. For the radius, the T1 is 6. What about T2? It is 3. What about T3? It is 1,5. Then now, because I'm dealing with the area now, how do you find the area for the circle? It is pi r squared. Pi r squared. So when I square the 6 here, I'm going to get 36. So it's going to be now 36 pi. Okay. If I square the 3, I'm going to get 9. It's going to be now 9 pi. Okay. If I square 1,5, now I get what? I get 2,25. Okay. 1,5 squared. 1,5 squared. It is 2,25. It is 2. Now this is 2. 2,25 pi. Okay. Because I'm dealing with the area now, my common ratio. So my common ratio here is going to be the 9 pi divided by 36 pi, which is 1/4. The 9 pi divided by 36 pi, which give us what? Which give us 1/4. Now that I have the common ratio, I can find the area. Now the sum of the areas of the first 10 circles is going to be my S10, okay? But I know that Sn for geometric equals to A into 1 minus R, the power n, by 1 minus R. So now S10, the 10 circles, is going to be, now our A is this 36 pi here, this one here, this is our A, okay, it's going to be 36 pi, and then multiplied by, open brackets now, we have what? 1, we have 1 minus what? The 4, you can see 0,25, that's also 1/4, 0,25. Now power 10, then divided by 1 minus common ratio, 1 minus 0,25, okay. So now calculators, what do you get here? Final answer, calculator. What do you get here? What do you get here? Calculator, what do you get here? Here I'm getting I'm getting 1 5. I'm getting 1 5. If I round off, I'm getting 150, comma. So I'm getting 150, comma 796. Getting 150, comma 796. But because I want my answer to the small places, it's gonna be 150, okay, 150, comma 80. These are centimeters squared. So this is the sum of the areas of the first 10 circles. Okay, hope guys we are together. Let us proceed now. Now they say that they say here, which circle has a diameter of 3 over 128? Which circle has what? Diameter of 3 over 128. But then because our pattern is dealing with the radii here, radii, the 6, 3, and 1,5, so it's better I convert from diameter to radii. I divide by 2. So if this is diameter here, my radius is gonna be 1 over 2 multiplied by what? By 3 over what? By 3 over 128. 128, okay? Which gives me my radius as what? My radius as 3 over 3 over what? 3 over, calculator here, let me find out now. If I say 2 times 128, it gives me here 256, ne? That is 3 over 256. 256. Now, actually, I'm looking for the circle with this radius, ne? Now, the radii also have got a geometric pattern, ne? Whereby we have the common ratio. Okay, we have our T1 there, our T2, then we have our T3, okay? So our T1 there for the radii, it is 6, and then followed by 3, and 1,5. Next, so from here I can get a common ratio, ne? The common ratio here is going to be 3 over 6, which is what? Which is 1 over 2, ne? So, now because I have the common ratio, and I have term, then I can use it for the geometric. I'm going to say that my Tn for geometric, my Tn equals to a common ratio power n minus 1. So in this particular case, I'm dealing with this term here. I'm going to find out which term has got this radius here. Okay, so I'm going to say that the 3 over 256 is equal to a, what was our a? It is 6 here, equals to 6. What about common ratio? 1 over 2 over 10 power n minus 1. Okay, so now here, if I simplify here and I divide by the 6 here, I'm getting what? I'm getting I divide by 6. What do I get here? So I have there 3 out of 256, then divide by 6. Here I'm getting 1 over 512 over 1 2, 1 over 512 over 512. Now should be equal to 1 over 2 to the power n minus 1. So my target is to get this n. Now 512 is the same as 2 to the power 9. So I'm going to say with the exponents, this one I can say 1 over 2 to the power equals to 1 over 2 to the power what? To the power n minus 1. That's our answer here. Yes, that's our answer here. Thank you so much for watching. See you in our next question. Bye-bye. Don't forget, if you don't understand and you are my learner at Lostek College, please come tomorrow morning and ask me. Or if you're in our tuition center, don't worry. We'll do it again online tonight, okay? Don't forget to share, subscribe, and like the video. Bye-bye. Oh yes, you are welcome once again. This is question 2, May, June 2024. They say consider the geometric series. Consider the geometric series that is 4 plus 2 plus 1 plus 1 over 2. They say, does this series converge? Justify your answer. Now, we said in our introduction that for the series to converge, the common ratio must be between what? Between but less than 1. So for that matter, let us find our common ratio here. Now for this series, our common ratio is going to be 2 over 4, which gives us 1 over 2. 1 over 2. So because 1 over 2 lies between -1 and less than 1, then the series converges, we say. Yes, converges. Yes, it converges. Why? Because the common ratio lies between -1 and less than 1. Then they say calculate sum to infinity. Now our sum to infinity is given by a over 1 minus common ratio. Now the a is the first term, which is 4, and then the common ratio, you saw it is 1 over 2. 1 over 2 here. So 1 minus 1 over 2, it is 1 over 2. So 4 divided by 1 over 2, it gives us 8. Meaning the sum to infinity is what? Is 8, okay? Then 2.2, there's a given summation from p equals to k up to 10 of 3 power p minus 1 equals to 29520. Calculate the value of k. Calculate the value of k. So now this is geometric, okay? And we need the value of what? We need the value of k. So what do we know about the geometric? Now this is sigma notation. We're looking for the k. Now they gave us the summation here, which you guys can see. The question says that the summation from p equals to k, okay, from p equals to k until 10, okay, of 3 power p minus 1 equals to 29, then 520, 29, 520. So here, how do you get the number of terms? Do you remember the number of terms here? Our number of terms, we say it's given by what? By the upper limit or upper boundary, which is 10, okay, minus lower, the lower is k, and then plus 1. So in here, it gives us 11 minus k. Now these are the number of terms in terms of k. Okay, so if you check here, when I put p equals to k, I'm going to have 3 power k minus 1. Okay. When I put p equals to k plus 1, I'm going to have 3 to the power k plus 1 and then minus 1. Okay. Then minus 1. And then when I put k plus 2, I'm going to get 3 to the power k plus 2, and then minus 1. Okay. And so many other times until I add p equals to 10, that is 3 to the power 10 minus 1, power 10 minus 1. Now this summation here, it gives us 29,520. Okay. Okay, so when we simplify this, what do we see? We see we have got 3 to the power k minus 1, then plus 3 to the power k, okay, and then plus 3 to the power k plus 1, and then plus many other terms until we say plus 3 to the power 9 should give us what? 29,520. Then from here now, I know this is geometric. I need to find the common ratio. So the common ratio, I can use 3 to the power k plus 1 divided by 3 to the power, which gives me 3 as my common ratio. So I know that the sum of geometric Sn equals to first term, open brackets, common ratio, power n minus 1 divided by common ratio minus 1. Now in this case, if I do substitute, I'm going to have the Sn whereby my n is 11 minus k. Okay, so it's going to be S11 minus k, S11 minus k, S11 minus k equals to A. Now our A is 3 power k minus 1, 3 power k minus 1. Then here I have the common ratio to the power n, but n is 11 minus k, 11 minus k, 11 minus k, minus 1, close bracket, divided by 3 minus 1, which is 29,520. Okay. So from here, open brackets here, I'm going to get 3 to the power k minus 1, then plus 11 minus k, plus 11 minus k, okay, then minus 3 the power k equals to 29,520, 29,520, and then multiplied by what? Multiplied by 29,520, 520 multiplied by 2. Now this 2 comes from this denominator here, which is 3 minus 1, okay? So here, if I simplify this again, I get the k minus k, it cancels out. Negative 1 plus 11, I get 3 power 10. So this is 3 to the power 10, okay, minus 3 to the power k, minus 3 to the power k is equal, if I multiply by 2, if I multiply by 2 here, what do I get? That is 29,520 times 2. It gives me 590 and 40. 590 and then 40. So from here, if I say 3 power 10 minus 590 and I must equate it to what? To 3 power k. 3 power k. So the 3 power 10 minus this 590 and 40, it gives me 9 here. So I'm getting 9 here equals to 3 to the power k. But you know that 9 the same as 3 squared. And so for that matter, at the same base, which is 3, then my k becomes 2. So k equals to 2. K equals to 2. That's our answer here. Hope guys we are together. If we are not together, don't forget you can reach us on 0785 2222041. Otherwise, we have to continue here. Next question here. That is also question 3. Question 3, May, June 2020 what? 2024. Question 3, May, June 2024. So in here, if you check what we have here, we have 3.1. Consider the quadratic number part. They give us 3 here, and then 7, and then 12, and then what must we do? Show that the general term is given by Tn equals to a half n squared plus 5 over 2n, okay? So here, if you minus 3, you get a 4. If you say 12 minus 7, you get a 5, okay? Then if you say 5 minus 1, looking for the Tn, but from our theory, we see that any quadratic Tn is given by what? By an squared plus bn plus c. and then whereby our 2a equals to d1, which is d2, which is 1 here, and our 3a plus b equals to 4, and our a plus b plus c is 3. So here you can start from here. Our a equals to 1 over 2, then 3a plus b, our a is 1 over 2, and then the b is what we are looking for. Then we move to the 4. Okay, so our b equals to 4 minus what? Minus 3 over 2, and which gives us 5 over what? 5 over 2. Okay, after getting a and b, we can get c by saying a, whereby the a is 1 over 2. Okay, which is 5 over 2, and then plus c, which we are looking for, equals to t1, but our t1 here is a 3. So 3, and so our c equals to 3 minus 1 over 2 minus 5 over 2, and therefore our tn equals to a, but a we got 1 over 2 n squared. What about our b? It is 5 over 2. Okay, 5 over 2n. Then the c is 0. That's what they wanted. Hope we are together. Let us proceed. Next question here. They say, what number must be added to tn minus 1 so that tn equals to 1, 3, 5, 2, 7? In other words, we're looking at which we can add to tn minus 1 so that tn equals to 1, 3, 4. What we are going to do here, let me get some space here. So now what I'm going to do here, I'm going to first of all equate my tn to 13572, and then I look for that n. After getting that n, I'm going to get tn minus 1. Okay, so here we go. We are saying here that our tn, this one here, our tn is equal to our tn, it is n squared over 2. Okay, or you can say half n, then plus 5n over 2 plus 5n over 2, but this must be equated to that number first, which is 13527, and then now I can multiply by 2. So I have n squared plus 5n equals to 2. Okay, so we are saying you multiply by 2. Okay, multiply 2 multiplied by what? By 1, 3. 5 to 7, 1, 3, 5 to 7. So here we are getting n squared plus 5n plus 5n. Then now here after multiplication I'm getting 270, 5, 4, 270, 5, 4 equals to 0, equals to 0. Now here you can use quadratic formula or you can factorize. Okay, so here if I use quadratic formula, n is plus 5, okay, then plus or minus square root of b squared minus 4ac, that is 5 squared, minus 4a, the a is 1 here, the c is negative what? Negative 270, a 5 and a 4, then divided by what? By 2a. Divided by 2a. Now calculator, what do you get? Calculator. Here I'm getting my calculator here. Negative 5 plus square root 5 squared minus 4ac. Okay, that is 27054. Okay, and then divided by 2, I get 162. So here I'm getting 162. Now in this case, my n should be a positive number, so I don't take the minus 1. Okay, because if I put a minus, my n here becomes, if I put a minus here, the n becomes negative 167. Negative 167. But because I'm dealing with the natural numbers, I don't take the negative. So remember that the question talks about tn minus 1. So if my n is 167, so the tn minus 1, it means I'm going to find the t of 162 minus 1, which is 161. By getting this 161, I come back to the original quadratic equation. The original, this general term, then I put to c. When I say 1 over 2 here, 1 over 2 into 161, okay, squared, then plus 5 over 2 plus 5 over 2 into 161. Now calculators, what do you get here? What do I get here? Calculator, let me check it out here. Times 161 squared, then plus 5 over 2 into 161. So here I'm getting 133.63. 33, okay. 63. Now don't forget the question was saying that what number must be added to this one so that I can get this, ne? So now the number to be added, let it be x, ne? Meaning that I'm gonna say like this now. I'm gonna say that this tn, remember the question says what number must be added, ne? So if my tn minus 1, I add the number x, I must get what? I must get the tn. So if I substitute here now, the tn minus 1 is 16113 what? 13363, okay. And then plus the number I'm looking for, which is the x, okay. So give me the tn, but the tn was what? The tn, guys, it is this one here, 131 13527, 13527. So when I subtract now to get my x, the number to be added, what do you get there? Here I'm getting 164. So the number to be added should be 164. That's our answer here. Hope guys we are still together. Let us proceed. Now next here, question 3.2, they say, given an arithmetic sequence at t1 equals to 8, t2 equals to 11, n equals to 41. What do we know about arithmetic? About arithmetic, different, isn't it? So, for that matter, remember I have the t, I have the t1, and I have the t2. Okay, so any arithmetic, I'm doing 3 point, arithmetic is given by tn, okay, tn equals to a plus n minus 1 plus n minus 1 times common difference d, isn't it? Now I have got the t1, that's my a, and the t2, that's my 11, so it means I'm going to have my tn. Remember that the tn here, they're equating it to 41. So if I equate to 41 here, I can get what I want now. Looking for n, so I'm going to say here, my a is 8. Go to the t1, looking for this n, okay? So my common difference is given by the t2 minus t1. So what is 11 minus 8? It is a 3, okay? Then equals to 40 what? Equals to 41. So guys, 41 minus 8, what do you get? 41 minus 8, what do you get? Talk to me. The 40 minus 80, that is 32. Then 32 plus 1, that is 33. Okay, 33. Now 33 divided by 3, I get 11. 11 plus 1, I get 12. So my n is 12 here. My n is 12. That's our answer here. So our n is 12. So it is T12. It is T12, which should give us 41. Okay, they say here, next question here, that a new arithmetic sequence P is formed using the term position and the term value of the given arithmetic sequence. For the new sequence, and the P11 equals to 2, and so on. Write down the value of P41. Now P41, now this is 41 here. Remember that our T12 from the previous question, our T12 equals to 41. So meaning that the P41, we just invert it, so that our P41 is going to be 12. It's going to be what? It's going to be 12. Okay. Now they say, calculate the value of the first term of the new arithmetic sequence. Looking for the A. So now, because I have a new arithmetic sequence, arithmetic Tn equals to what? Equals to A plus n minus 1 times common difference, common difference D. But now we're calling it Pn. So I'm going to say Pn equals to A, okay, equals plus n minus 1 times D. Now if I talk about P8, the P8, I'm going to substitute now. I'm going to say A, okay, plus 8 minus 1, which is 7 times D, making it 7D. They said P8 equals to 1. I can say this is equation 1. This is equation 1. So then, now the P11 equals to A plus, now 11 minus 1, that is 10, times D, 10D, okay? Now, they say the P11 equals to what? Equals to 2 here. And so this is equation what? Equation 2. Now, the two equations 1 and 2, I can solve them simultaneously. So I'm gonna say that equation 1 minus equation 2, 1 minus 2. Now, if I say A minus A, I get a 0. Then 7D minus 10D, 7D minus 10D, it's going to give me 1 minus 2. So 1 minus 2, it gives me negative 1, negative 1. And so negative D, negative 3D equals to negative 1. So divided by negative 3, our D equals to 1 over 3. After getting D, the question is interested in A. So from this equation 1, if I say A plus 7D, A plus 7D should equal to 1. And now that I know the D, I can find my A by saying A equals to 1 minus 7D. But what is our D, guys? 1 over 3. Okay, so calculators, my A, it gives me what here? So 1 minus 7 over 3. 1 minus 7 over 3. Yeah, it gives me negative. So my A is negative 4 over 3. Negative 4 over 3. Yeah, that's our answer here. Alright, I think if you have got any questions, don't hesitate to reach us on 0785 222 1, or you can click on the link below to join our extra classes, or you can come tomorrow and see me at the college. That is technological Kwani, and we sort it out. Thank you so much. Bye-bye. Oh yes, this is question 2. Question 2, November 2023. It says, given the arithmetic series 7 plus 12 plus 17, what must we do? Determine T91. What they're saying is arithmetic, then you have a common what? A common difference, right guys? So we have 7 plus 12, then plus what? Plus 17. So being arithmetic, what is 12 minus 7? 5, ne? What about 17 minus 12? Also 5 here. So looking for T91. So before we get our T91, we need to find our Tn. Let's find our Tn. By using Tn equals to the first term plus n minus 1 times d. And so our Tn is given by, what is our A from here? Our A is the 7, let me 7 plus n minus 1. What about our D? Our D is the 5, ne? So because we're looking for the T of 91, I'm going to say T91 equals to 7 plus, now 91 minus 1 is 90. It will be 90 multiplied by 5. So finally, we get which answer here? I'm getting 457. 4, 5, and 7 here. Okay, then next, they want S91, 91 terms. Now our Sn equals to n over 2, okay, into the first plus, because we know our first term, we're gonna put it, okay. So our first term, you see it is 7. Now the last term is this one here, which we just got, that is 4 what? 457. And so with the calculator, what do you get there, guys? What do we get here? I'm getting 2 112. Get 111 and another 2. So that was 2.1.2. The next question here, they say calculate the value of n for which Tn equals to 517. So what we do here, we are going to say that our Tn is 517. Okay, but we know the expression for the Tn, so we can use it. When I say our Tn equals to 517. But we know that our Tn is this one here. So I'm going to say that 7 plus n minus 1, okay, multiplied by 5 should be equated to 517. So minus 7, get n minus 1 multiplied by 5, ne? To give us 510. To give us what? 510. So this 510, if you divide by 5, you have n minus 1 equals to 102. 102 plus 1, it gives what? 103. That's our answer. 103. Hope we are together, guys. Okay, let us proceed. Next question here. What does it say? Question 2.2. They say here that the following information is about the quadratic number pattern, okay? So they're giving us T1, T2 minus T1, and T3 minus T2. So, meaning that if this is our T1, okay, and then our T2, and then our T3, remember the sign is quadratic in it, maybe 7 T4 here. Now they say here that our T1 is 3, so I'm going to put a 3 here. Where is T1? I put a 3. Okay, anyway, let me repeat now. This is my T1 here, but they say it is what? It's a 3, so I'm going to put a 3 here. And then they said that T2 minus T1 is 9, so T2 minus T1 minus, put it here. And then the T3 minus T2, they said is 21. And so, because of this now, they said it's quadratic, don't forget. The 21 minus 9, we get 12. Okay. So, the question says, show that T5 is what? Is 111. So, tilt here. So, what I'm going to do here, please note that because of the 3, I'm going to say 3 plus 9 equals to 12. So, the T2 is 12. Are we together? Then check here, 9 plus 12, you get 21. So to get my T3, I'm going to say 12 plus 21. What do you get? You get 33. Okay. Now, because of the 12 being the second difference, I'm going to say 21 plus 12. Okay. Also give us what? 33 here. You see? So now, to continue, 33 plus 33, it gives me what here? 66. That's our T4, 6. And then now 33 plus 12, what do we get here? 33 plus 12, we get 40 what? We get 45. Now to get our T5, I'm going to say 66 minus 45, plus 45. Here I'm getting triple 1. Okay, that's our answer here. Next question, they say, show that the general term is 10 equals 6n squared minus 9n plus 6. Okay, now that we have the sequence properly here, we can find our Tn. What do we know? We said that any given quadratic is given by Tn equals to an squared, okay, plus bn, and then plus c. So now our d2 is 12 here. We know that our twice a, our 2a is d2, which is 12 in this case. By 2, a becomes 6. Our a becomes 6. After getting a, we said 3a plus b. 3a plus b give us d1. 3a, but the a is the 6, plus the b that we're looking for should give us d1, which is what? Which is 9. So 9 minus 18, we get our b as negative 9. Then we also know that when we add a plus b plus c equals to t1, a plus b plus c should give us the t1. But then our a is the 6, our b is negative 9. So if you say 6 minus 9, and our T1 is 3. If you say 6 minus 9, you get negative 3. So negative 3 plus C equals 3. It becomes a positive 3. So ours becomes a 6 in this case. And therefore, our Tn is given by what? By 6 by 6n squared. Okay. And then minus 9n. And then plus 6 as required. That's our answer here. Let us proceed. What are they saying here? Next question. They say, show that the pattern is increasing for all any in natural numbers. Now, for the pattern to be increasing, we're going to employ the gradient. Okay. Now, our Tn from here, our Tn, this is question 2.2.3. You're saying that our Tn for question 2.2.3, our Tn equals 6n squared, then minus 9n plus 6. So from here, we're looking for ever increasing pattern. Let us differentiate. Now, if I differentiate t with respect to n, here I'm gonna get 12 what? 12n minus 9. So for increasing value, our derivative or our gradient 0. So our 12n minus 9 should be bigger than 0. So in this case, our n is going to be greater than 9 over 12. And if you simplify 9 over 12, you get what? You get 3 over what? Over 4. Now, because if you check here, after 3 over 4, you get your first natural number, which is 1. So, meaning that for all what? For all n are the natural numbers, our Tn is ever increasing. Tn is ever increasing. Is ever increasing. Is ever increasing. All you can say is always increasing. Now somebody can say, what are you talking about exactly? Because for any natural number, when you put it here, you're gonna get what? You're gonna get the answer bigger than 0. Hello? If you put any natural number here, whether it is 1, whether it is 2, 3, 4, 5, and so on, you're gonna get a number, the answer which is bigger than 0. That's why it's gonna be ever increasing. Okay. Hope we are together, guys. Yeah. Come on. Okay. So you do so. I'm gonna make this now. So guys, this is November 2023, and the question 3 about the geometric series. They say here, given geometric series 3 plus 6 plus 12 plus so many until n terms, write down the general term for this series. Now, being geometric, our Tn, and we need common ratio first. Common ratio. Now here being geometric here, our common ratio, which gives us what, guys? Which gives us 2. So, and our first term is this 3 here. So our Tn, our general term Tn, equals to A, which is the 3, by 2, which is the 2, then power n minus 1. That's our general term. Then they say calculate the value of k such that the summation from p equals to 1 until k of 3 over 2 into 2 power p equals to 98301. We're looking for the k value. Ne? Okay, so guys, if you see what I have here, let me get some space here. If you see what I have here now, you guys can see that the question talks about calculate the value of k, but they're giving me something like this. Summation from p equals to 1 of k into 3 over 2, and then 2 to the power p, 2 to the power p, and they say equals to 98301. Okay, so now this one I can rewrite it properly. You see this 2, when you take it up, it's gonna be 3 times 2 power p, then minus 1. That's what we had already. So in other words, we will look for the sum of the what? The number of terms from p equals to 1 until k. So we're gonna look for the sk here. So sk, now this is geometric, guys. Don't forget that our common ratio is 2 and the first time is 3. So the sum of the geometric series Sn equals to A, open brackets, common ratio power n minus 1 divided by r minus 1. Now they said here it must equal to this number here, so I'm gonna say our A is the 3, so this 98301. So I'm gonna say 3, open bracket here. The common ratio is 2, so this is 2. Then the power, now because our number of terms here, it is k minus 1 plus 1, which also gives us k minus 1 plus 1. It also give us what? Also give us k. So in other words, I'm looking for sk, so I'm going to be 3 into 2 the power k, then minus 1 divided by 2 minus 1 to give us 98301. Okay, so here 2 minus 1, I get a 1. Then 98301 divided by 3, what do you get? 98301 divided by what? By 3, what do you get? So here I'm left with a 2 to the power k minus 1 equals to Now if you divide there by 3, let's check it here. That's 98301 divided by 3. You get 32767. You get 32767. Then now plus 1. The 767 plus 1. So here we have 2 power k 3 equal to 3, 2, 7, 6, 8. Actually, we are adding 1. 7, 6, what? 8. Now, the 32768 in powers of 2, if you check it here properly, the 32768, let's check it here. What does it give us? Here, if I write it here, and I set 32768, I get the factors here, 50 factors. It gives me 2 power 15. Okay, so I have here. So the 2 power k equals to what? So it is equals to 2 power 15. Okay. So 2 power k the same as 2 to the power 15. Same as 2 the power what? To the power 15. Okay, so here, because I have the same base, my k equals 15, guys. K is 15. The k is 15 here. That's our answer here. Let us proceed. Next question. Next question here. That's question 3.2 now. They say here that a geometric sequence and the arithmetic sequence have the same first term. So here, they said you have geometric, and then arithmetic. Now they're saying that same first term, meaning all our T1 is A. Also for arithmetic, T1 is A. They proceed. The common ratio is 1/3 for the geometric, so our common ratio is 1/3. And then the common difference for arithmetic is 3, so our D is 3. Okay. Then they say that the sum of 22 terms of that arithmetic sequence is S22 for arithmetic sequence is 734 more than the sum to infinity. Is 73 more than the sum to infinity. In other words, when we sum the 22 terms of arithmetic, that means S22. This is arithmetic here. S22. Okay. Is equal to 734 to infinity, more than the sum to infinity. And so what must we do? They want the value of A, that's the first term. So now this is 734. How do anybody who remembers? It is A divided by 1 minus common ratio. which is a third. Then the sum of the first 22 terms for the arithmetic, we know it is n over 2. N over 2. It is n over 2 into 2a plus n minus 1 times common difference. Okay, so here we go. I'm going to say, now the n is 22, I'm going to say equals to 22 divided by 2, open brackets here, 2a, our a is what we're looking for, plus n minus 1. Now 22 is the n, so minus 1, 21 times d, 21d. Okay, so we can proceed here. This here. 1 minus a third, that is 2/3. Divided by 2, that's going to be giving us 3a over 2. So we have what? This is 7, 3, 4 plus 3a divided by 2 is equal. Now here if I divide by 2, I'm going to get 11. Equals to 11 into 2a plus 21d. Okay. But I know the d. Yes, they give us the d here. They said the d is 3. So 21 times 3. 21 times 3. Okay, so here, let's finish up now. What do we have? Here I have, don't forget that 734 plus 1,5, 1,5a equals to 11 into 2a. Now if you multiply 21, that is going to give us 61, 63. Okay, open brackets here. Here we still have 734 plus 1,5a equals to what? 22a plus, now 11 times 63, what do you get? 11 times 63, you're getting 693. Okay, so collect like terms here. Now the 734 minus 693, what do you get? 734 minus 693. On this. And then what about 2a minus 1 comma what? 1,5a. Okay, this is 1,5, don't forget. This is 1,5a. So the 22 minus 1,5, what do you get here? I'm getting 20,5a. 20,5a. So divided by 20,5, our a becomes 2. Our a becomes 2. Alright, thank you so much for watching. Catch you in our next video. Don't forget to hit the like button and share the video, and also subscribe for more such videos. Bye bye. Oh yeah, I'm grade 12. How are you today? This is Patrick Kamala once again. Now today we are looking at May-June 2023. And please students, the best way to benefit through these videos, like I said in physics, you can pause the video and then try the question first. When you are done, then you can mark by watching the video. Alright, this is question 2, May-June 2023. It says, given the geometric series 1 over 5 plus 1 over 15 plus 1 over 0.5 and so many more, the question says, is this a convergent geometric series? Justify your answer with the necessary calculations. Now from our theory, we know that if the series is going to be convergent, we need to know its common ratio first. Okay. We need to know its what? Common ratio. So let's first get the common ratio here. So our common ratio here will be given by what? By T2 divided by T1. So T2 divided by T1. Then we see what happens here. Okay, so our T2, it is 1 over 15, okay? And then divided by 1 over 5, ne? Divided by 1 over 5. It gives us what? It gives us 1 over 15, okay? 1 over 15, and then times the reciprocal, multiply by reciprocal, so the 5 comes up, ne? So it gives us what now? It gives us 1 over 3. 1 over 3. So here we say the answer is yes, okay? We say yes because the common ratio, which is 1 over 3, lies between what? Lies between -1 and less than 1. That's our answer. So the answer is yes because the common ratio, which is 1 over 3, lies between -1 and less than 1. Then they say, next question here, calculate the sum to infinity of the series. Now the sum to infinity has got a formula. I think guys you know it, that sum to infinity equals to a minus common ratio, ne? 1 minus common ratio. So if we do it here, our sum to infinity divided by what? A. Now our a is the first term here, which is 1 over 5, ne? Okay. Then divided by 1 minus common ratio, that is 1 over 3, okay? So in here, it gives us what? If you can decide, we are gonna say this is a 1 over 5, 1 over 5, then divided by 2/3. As a third is 2/3, when I say divided by 2/3, which becomes times what? Times 3 over 2. And so it gives us 3 over 10. So our sum to infinity is what? Is 3 over 10. That's our answer here. Hope we are together. Let us proceed. Then here, they say that 2.2, they say here, an arithmetic key and the geometric sequence are combined to form the pattern, which is given now of x, a third, 2x, 1 over 9, 3x, 1 over 27. Write down the next two terms of this pattern. Now you see the x and the 2x and the 3x and this one here. So the x's, they form the arithmetic because this is x, 2x, 3x, like they've got a common difference. And then they are third and 1 over 9. So from 3 to 9, from 9 to 27, multiplied by 3, there comes 4x. Ne? Meaning that the next two terms, I'm going to have 4x, and then when I multiply 27 by 3, I get 81. Ne? So it becomes 1 over 81. 1 over 81. That's what we have here. Then they say now Determine the general term for the ordinary. Write down your answer in terms of x. Now the odd numbers, we've got 1, 3, 5. In that case, we have the arithmetic, okay? And because of that, the common difference here, I can see it is x. So we know that for any arithmetic, the tn is given by what? By the first term, n plus what? Plus n minus 1 multiplied by d, multiplied by common difference. Okay, so in here is going to be our a is the x, okay, and then plus open bracket n minus 1. Now the common difference is also x, because 2x minus x, you get x. So this one here, when open brackets here, it gives us what? It gives us x. It gives us x plus nx, okay, plus nx minus x. So you can see the x's are going to cancel out. So in this case, my answer is going to be nx. That's my answer for the general term of the odd terms, okay? All right, then next here, they say calculate the value of P26. Now P26 is what we're looking for. So in this case, it means what? Now 26 is even number. So we're dealing with the even terms now. So the even terms here, this is T1, okay, this is T2, okay, and this is T3. And so, as you can see, these are the geometric, and because these are equally distributed, the odd and even, from T1 to T26, we have got 13 of each. We have got 13 of the arithmetic and 13 for the geometric. So, mean that my P6 is going to be the P6, or the P26 is going to be the T13 of the geometric. Okay, I repeat, because from T1 until 26, I have got two types of terms. The first is some 13 terms, they are arithmetic, and the other 13, they are geometric. So I'm wondering about what? Geometric. The nth term, the Tn for geometric, we know that Tn is given by what? Is given multiplied by common ratio, power n minus 1, okay? So if I talk about T13, it's going to be first term. Now the first term you see it is 1 over 3, so this is 1 over 3, 1 over 3, then times common ratio. Now the common ratio here, because you're multiplying by a third, okay, get the next one here, it's 1 over 3 as well, 1 over 3. So looking for T13, it's going to be 13 minus what? 13 minus 1 here, okay. Now if I simplify this, I'm getting, now 1 over 3, the same as saying 3 power negative, right? And then here, in the brackets here, I can also say 3 power negative 1, okay? And then this is 12, okay? So as you can see, if I continue simplifying here, I'm going to get 3 power negative 1 minus 12, okay? So finally, my answer is going to be 3 power negative what? Negative 13. Okay, now this same answer, if you want, you can write it as 1 over 3 the power 13. So the same thing altogether. So you can leave your answer like this. Okay. Hope we are together, guys. That's our answer here. So we're here now on this question here. They say if the summation from n equals to 1 up to 21 of Pn is 33,5 of x, determine the value of x. Okay, so you need some big space here. They're saying that, I think I better do it here. Okay, and they're saying that if the summation like this, okay, they're saying if the summation from n equals to 1 until 21 of Pn. Remember, Pn is a combination of Pn equals to 33, and then they say determine the value of x. Now don't forget that from the beginning, this Pn is a combination of the geometric and the what? Arithmetic. The Pn is a combination of geometric, okay, that's a 10 for geometric, all together, 10 for geometric, and then 10 for what? For arithmetic, okay, and then plus the Tn for the what? For arithmetic. So now, in this case, because in the order given there, if you look at my order one more time, let's check it here. Let's check the given order here. The order given here, we have x 1 over 3, 2x. So it is arithmetic first and then geometric. Okay, so then geometric. But what do I know? That the Pn, okay, I'm starting with arithmetic, because I'm beginning with the x there. So arithmetic that any times given by what? By a. Actually, I got my nx. Hope you remember, guys. I got my nx for arithmetic here, which was my general term. So this is nx, okay. And then for the geometric, we know it's given by the first term, which was 1 over 3, right? And then common ratio, also 1 over 3, right? Okay. Then power n minus 1. Okay. Now the question said that they are summing up now, that is n1 and up to 21 to give us 33,5. Okay, so now in terms 21 terms, it means that we're going to add from T1 until 21, right, guys? So now 21, it is an odd number, which means that the last down for the odd, which is the arithmetic. And so from the first 20, remember that they are evenly distributed, okay? And so meaning I'm gonna have 11 terms. Remember, to get 10, I'm gonna have 11 terms for the arithmetic, and the 10 terms we're gonna see here, it's gonna be 11 terms. So that here, this summation here, the summation of the 21 together combined, the summation for the 11 what? For the 11 arithmetic terms, okay, and then plus the summation or the sum for the 10 terms for the geometry. Okay, so now I'm gonna say that here, now sum for this one here, remember I can use the formula. What does the formula say in that case? The formula says what? That I can use n over 2 into the first and the last term, right? I can use I can use n over 2, okay, n over 2, open brackets, then the first term and the last term, that's for the arithmetic, I can use, I not given by a, okay, open brackets, 1 minus common ratio, the power what? The power n, okay, divided by 1 minus common ratio. Now, when you substitute everything here, you must equate to what? The given number, which is 33, 5, 3, okay. So in here now, get more space here. Get more space here now. Don't forget this. On this one's at 11. Okay, so I'm gonna say here, this one is gonna be my n. It is 11. Okay, it's gonna be now 11 over 2. Okay, 11 over 2. Open brackets here, and then my first term is x. Okay, my first term is what? It is x. So this is x here. Now the last term, because there are only 11 terms, 11x, and then plus now, for the geometric, there are 10, don't forget. I'm gonna say 1 over 3, that was our first term, 1 over 3, open brackets now, 1 is a third, then 1 minus the power n, and then divided by 1 minus common ratio, a third. Okay, so here then I must equate the given sum, which is 30 what? 35. Okay. Now here, if I say x plus 11x, I'm getting 12 divided by 2, 6 times, I get 6, I get 66x here. And then from the calculator, what do you get here? When you compute a third into 1 minus a third power 10 divided by 1 minus a third, what do you get here? Here I'm getting, when I round off properly, I'm getting 0.5. 0.5 here, okay, and then equal 33.5. 33.5. Okay, so here, if I say minus 0.5, I'm getting my 66x equals to 33. Equals to 33. Okay, so divided by 66. Divided by 66. And so here, I'm getting my x equal to 1 over 2. That's our answer here. Hope guys we are together. That's our answer here. Let us proceed. Next question. Yeah, now this question is 2023 May June, question 3. It says a quadratic sequence has the following properties. The second difference is 10. The first two terms are equal, that's t1 equals to t2. Then they say that t1 plus t2 plus t3, you get 28. They say here, show that the general term of the sequence is what? 10 equals to 5n squared minus 15n plus 16, and get a set of 6 marks. Okay, so we say that quadratic sequence has got a second difference, and that which you call the d2. Okay, so if you remember, if this is our quadratic here, let's say this is t1, and then t2. Okay, then t2 here, and then t3, and then t3, okay, and then t4, okay, and then t4, then t4 here. Now we know that, okay, they say here t1 equals to t2. I'm going to call them tt. So this is t, and this is t. Okay. And and then this is t4. Okay, then I know that with the quadratic, I must subtract when I subtract here. Now t minus t, I'm getting a 0. Okay, what about here? I'm gonna have what? I'm gonna have t3 minus what? Minus t. t3 minus t. But then being quadratic, we have what call as the second constant, but d2 they say it is 10. This 10 here, so I'm gonna put the 10 here. Okay, all right. Now they're saying also that when you add t1 plus t2 plus t3, you get 28. Okay. Okay, so when I add t1, plus t2 plus t3, I must get what? I must get 28. Okay. So this one equation I'm gonna use. Okay. Let's get 28 here. So this is 2t2, 2t rather, 2t plus t3 plus t3. I must get what? 28. Okay, so but I know that if I know this information here, tn equals to an squared, okay, then plus what? Plus bn, right guys, and then plus c here, whereby we said that our 2a should give us d2. Now our d2 is this one here, which is the 10, equals to 10. So to get my a as what? As 5, okay? Get a as 5. Then from here, because we have the d1, this one is d1 here. Okay, this one is d2. Okay. So because I have the d1, I'm gonna make use of it. I'm gonna say also 3a plus b. 3a plus b should give us what? No, should give us d1. Hope you remember that, guys. Should give us d1. Okay. And then here I'm gonna say 3a, but I know the a is 5. Okay. Then plus b equals to d1, but d1 is 0. So therefore my b is minus 15. My b is minus what? Minus 15. Okay, now I'm short by c, and so far I have the a and b, meaning my tn so far equals to an squared, but the a is what? The a here I got a 5, that is 5n squared. 5n squared. Then the b is minus 15, so minus 15n, and then plus c. I don't know the c yet, okay? But then from this given equation, I can get my what? I can get my t3. Okay, in terms of present time for the question here, they're saying here that the second difference is 10. We use that. They say here the first two terms are equal. We did that. And then they say the sum should give us 28. When you add t1 plus t2 plus t3, you get 28. So now, what next here? Let us think together. So here, meaning that because I have I have this tn for now, mean that I can talk about my t3. So my t3 is gonna be 5 into k. But then we see, what do I do in that case? What do I do in that case? I should do what? What do I do here, guys? What do I do here? Now, from the given information again here, we can see this, guys. This one here. When you say the t3 minus t and then minus 0, get 10, okay? The t what? The t3, 3 minus t minus 0, I get 10. I get 10. This common second difference here. I get that 10, okay? Meaning that my t3 equals to t plus 10, equals to t plus 10, equals to t plus 10. Okay, so for that matter, when I come to this equation now, where I have the t3, I'm gonna put what? I'm gonna put t plus 10. I'm gonna say now, it's gonna be now 2t plus t3 is t plus 10. T plus 10 should give us 28. Should give us 21, 28. Minus 10, you get 18. So our 3t equals to 18. Equals to 18. Divided by 3. The t becomes what? The t becomes as 6. Okay. After getting t as 6, so I can be able to get now my what? I need to get my. I'm looking for this now. My t is what? My t is 6. Okay. So what does that mean? Because I've got my t3 here and my t is 6, I'm gonna use the 6 plus 10 as my t3. Don't forget I have that now my t3, because I have the t2, I may have the t. My t3 from here equals to t plus 10, but t is 6, and then plus 10. What do you get, guys? You get 16, right, guys? You get 16. But then, so far, my n, though it's not complete, my tn is given by what? By 5n squared. By 5n squared. Okay. Then minus 15n. Minus 15n. And then plus c. So now I can get my c from here. If I t3 is 16, I'm going to say the t3, okay. Now t3 means wherever there is any put a 3 equals to 5, okay. Open brackets here, I put a 3. I'm gonna say squared now. Minus 15 into a 3, okay. Into a 3 here. Then plus c should give me the t3, which we see is 16. Which we see is what? Is 16. Okay, so from here, you guys can see that now 3 squared is 9, and 5, that is 5. Put 5. What about 3 times 15? Also 5. Then plus my c here should give me 16. Now, what does this mean to us? Therefore, our c is 16, and so therefore our tn. When we said we're supposed to show, therefore our tn is going by what? Going by 5n squared. Okay, 5n squared minus 15n. Then we know the c now. The c is 16, so plus 16. That is 8 plus 16. Okay, all right. That's what we have here. That's what we have here. That's what we have here. Then they say here now, is two set sequence justify your answer? So the calculations. Okay, they're saying that 216 a term in the sequence. Justify your answer with necessary calculations. Now, okay, because we have the tn given by what? We have the tn 5n squared, 25n squared, tn equals 5n squared. Okay, 5n squared, then minus what? Minus 15n, minus 15n plus 16. Okay, now the question says here, is this 216 a term in the sequence? Out if we can get any value as a natural number with the 216, then they would say it is yes. Okay, so I'm going to equal to 216. Okay, 216 here. So I have now 5n squared, 5n squared. Okay, then minus 15n, minus 15n here. Now the 16 minus 216 becomes minus 200, minus 200 equals to 0. So if I divide by 5, I get n squared minus 3n. Okay, then here minus 40, right? Minus 40 equals to 0. So do I have any factors? Any factors here? When you multiply, get minus 40, and when you add, get negative 3. That is 5 and 4. Eh? So I can have n minus 8 into n plus 5, right guys? And 5 equals to 0. N should be a natural number. Like you see here, when n equals to 8, that's our answer here. So because the T8, because it gives the 216, so here it's going to be what? It's going to be yes. We say it is yes. Why? Because our T8 gives us what? Gives us 216. That's our answer here. All right. Let us proceed. Next question. Yeah, to proceed, now it is this question 2, 2022 November. They said that the first term of a geometric series is 14 and the sixth term is 448. Calculate the value of the constant ratio. Okay, so to get our common ratio, in this case, I think is geometric, right? So being geometric, what we know? Guys, talk to me. that for a given geometric series, our Tn is given by what? Is by the first term, okay, by the common ratio, power n minus 1. Power n minus 1. Okay, so here they give us the this 14 and then this 10. Now the 14 is our stem, right? The first term, yeah, that's our T1, which you can call this our A here, or T1. So here, now the T6, the saying is that I'm gonna say here T6, meaning sixth term, okay. A, but our A is 14. I'm looking for the common ratio, okay. So common ratio, because if you talk about T6, might be 6 minus 1 here. 6 minus 1, 6, 1, and then should be equated to what? This given number, which is the 448. So 448 equals to 448. Okay. So what do we do here to get our common ratio? Can you talk to me now? I can divide by 14. Divide by 14. Then divide by 14 here as well. What do you calculate as? What do you get in that case? What do you get? If we divide by 14, the common ratio, power 5, equals to what? Equals to 32. Equals to 32. How do you get it out from here then? What do we do in that case? We find the fifth root. In other words, we can take like this. We can take the fifth root. We can take this root on both sides. Okay, so it becomes 5. Becomes 5 here. Okay, so that is it. The common ratio is 5. Rather, is 2, sorry, is 2. Okay, that's our answer here. Then they say next here that, what must we do next? They say, determine, they're saying here, determine the number of consecutive terms, okay, that will be added to the first 6 terms of a sum of 114674. I repeat, determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain the sum here, which you see here. So, meaning that we have got the sum of the first 6 terms, okay, then plus another sum to give us this sum here. Hope it makes sense to you. Like this, it means that we have, okay, we have what, guys? We have the sum of the first 6, are we together? Then plus a sum of certain terms, I'm going to call Sn. When you are done, they should give us what? They should give us this sum, which is 114, and then 674. 674. So now that we know the common ratio, it is 2. How do you find the sum of geometric? We know it's given by our Sn, okay, for geometric, by A, open bracket, ratio, power n minus 1 divided by common ratio minus 1. So talk about sum of the first 6. I'm going to say A second. Now, am I A? Our gave us 14. Let me check in. there is 14 here. Okay, you can see that. So I'm gonna put 14 here. I'm gonna say 14 here. It's gonna be 14. Okay, open brackets. And then these are 6 terms. The common ratio is 2. So 2 power 6 minus 1, right? Divided by 2 minus 1. Then plus Sn, which I'm yet to know. But I'm looking for the number of times here. So plus A, which is 14. Okay. Into my common ratio, which is 2 power n minus 1. Okay. Divided by 2 minus 1. Should be able to give us what? Give us the 1146 24. Okay, so from here, here I can do what? Calculator. What do you get here? Here I'm getting, when I simplify 14, it gives me 882. I'm getting 882. So this is 882. This is 8 with a 2. Okay. Then plus here, this is 14. This is 14. Okay. Open bracket, 2 power n minus 1. Okay. The equal to 114. 674. So if I subtract the 882 from this side, I'm remaining with what? 113 792 equals to 14. Okay, let's see, 2 power n minus 1. 2 power n minus 1. So now I'm going to divide by 14. Divide by 14. And then plus 1. Okay. So divide by 14. Divide by 4 on this side as well. My 2n minus 1. 2 power n equals to, what do you get your calculator? What do you get here? Calculator. So dividing by 14. What are you getting? So here I'm getting 8128. 8128. 8128. So I've got 2 power n equals to 8129. Okay. Then now if I take the log now, okay, let's set my n. Now I'm solving for exponential now, so I'm going to change it to log notation. N equals to log base 2 of 8129. Okay, calculators, what do you get here? What do you get here? On my calculator here, I'm getting 12, 989. So approximately my n equals to 13 terms in total. Okay, 13 terms. Okay, so because n is 13 terms, but I wanted to know how many terms to be added. 6 terms. So what is 13 minus 6? I get 7, which means I must add how many terms? The 13 minus 6 gives me 7. Okay, gives me 7 terms, which means 7 more terms should be added. 7 more terms should be what? Should be added. Okay, yeah, that is it, guys. That is it here. Let us proceed. Next part of the question. What does it say? They say here now that here, if the first term of another series is 448 and the sixth term is 14, calculate something in front of the series or something. Okay. Okay, saying here. All right. If the first term of another series is 448 instead of the 14, okay, and then the sixth term is what? Is 14. Calculate the sum to infinity. So guys, what we know about sum to infinity? How do you find the sum to infinity? Sum to infinity, we know the formula says that what? Our sum to infinity equals is given by this point. Oh yeah, guys, this is a continuation. I had some challenge with my software. Now we stopped here after getting 13 terms. After getting 13 terms, remember the question was saying that determine the number of consecutive terms, 36 terms of the series in order to obtain the sum of what? Of this value here. So if you check what we have here, we're looking for the number of terms. Which number of terms we get using this equation here? Get this equation here, this one here. Okay. Now after getting the n here, it's n number of terms which give us this value here. But because we're looking for how many are short to top up, we simply say then that now it is gonna be the 13 terms, okay? The 13 terms minus 6 to give us 7 terms. So in other words, it is 7 terms to be added to the 6 so that the sum is what? Is 674. Okay, let us proceed now. Need some space here. Need some space here. Need some space here. Okay, so the question continues to say, let's check it again. It says that what? Okay. The question continues here. And the sixth term is 14. Calculate the sum to infinity of the new series. Okay, so we know to get the sum to infinity, we need to use the formula. What does the formula say? That sum to infinity equals to a divided by what? Divided by 1 minus common ratio equals to a divided by ratio. Okay, so now here, now they're saying that the first term is 448 now, okay? So let's work out now our Tn for this new one. Tn equals to a, okay? Equals to a, the power n minus 1, okay? So in this case, now we're talking about the T6, So our T6 again, our T6 is going to be given by what? By a. Now this time the a is the 448, That is 448, and the common ratio yet. So this is common ratio, but we notice the sixth term, So power 6 minus 1 Okay, then equals to what? They say it is still 14. Okay, so from here now, to get a common ratio, we divide by 4 for 8. Then it becomes r power 5, ne? Okay, equals to 14 divided by what? Divided by 4 for 8. Divided by 4 for 8. So from here, our common ratio given by what? So here gives us 1 over 32. 1 over 32, okay? And so the common ratio, we find the root, ne? We find the fifth root of 1 over 32, and in that case it becomes what? It becomes 1 over 2. 1 over 2. So after getting the common ratio, now we can find out sum to infinity by saying sum to infinity equals to a, which is what? Which is the 4 for 8 now, okay? 4 8 divided by 1 minus common ratio, which is 1 over 2 here. And so we get what? Calculators. What do you get? Here I'm getting 896. Getting 896. That's our sum to infinity. Okay. The next question here, they say if equals to 0 up to k of this one is this, determine the value of k. Now these questions are very common, and so as we do this, please, I want you to pay attention because they are really common. These are really common questions. These are really common questions. Looking for some space here. Looking for some space. Okay. All right. So they say something here. They say that that's 2.2. Okay, I need 2.2 now. I need your attention. They say if the summation, okay, from p equals to 0, from p equals to 0 up to k of 1 over 3 p, then plus 1 over 6 equals to 20 whole numbers and 1 over 6, ne? Okay. Determine what? The value of k. What do we do here? If I put p equals to 0, I'm going to get 1 over 6. Okay. Number is summation, ne? If I put p equals to 1, I'm going to get 1 over 3, then plus 1 over 6 as my next term. And then if I put p equals to 2, I'm going to get 2 over 3, okay? 2 over 3 plus what? Plus 1 over 6, okay? And then I continue until the last term, which is what? Is k. I put p equals to k. That means k over 3 plus 1 over 6 plus 1 over 6, okay? So now when I add all these terms, I should get what? I should get 20 whole numbers and 1 over 6. Hope we are together for now. So from here, yes, so from here, I can see that if I simplify, I'm going to have here 1 over 6, then plus. So this is 2 over 6, 2 plus 1 is going to be 3 over 6. 3 over 6. Yeah, it's going to be 3 over 6. And then next, it's going to be here So multiply by 2 again, it's going to be 5 over 6, okay, over 6, and then plus many terms, okay, and then plus what? Plus k over a plus 1 over 6, that's 1 over 6, then equals to 20 whole numbers and what? And 1 over 6. Okay, so from here, I think you can see that the common ratio is 1 over what? 1 over 6, ne? 2 over 6, yeah, 2 over 6, which is 1/3. So I mean the common difference. The common, you can see it is what? The common difference, I can see it is 3 minus 1, that is 2. So common difference is 1/3. Even here it's also 1/3. So being arithmetic, I'm looking for k, don't forget. So because I have the first and the last terms, then I'm going to let me first forget my number of terms. Now here my number of terms, don't forget our number of terms is given by the upper limit, which in this case is the k, minus lower, which in this case is the 0, then plus 1, which gives us what now here? Which gives us k plus 1. Now that k plus 1 shows us the number of terms we are dealing with in this summation, okay? So now our SN for arithmetic is given by n divided by 2 into the first term, then plus the last term, like this, okay? Now in this particular case, my n is k plus 1, so it's going to be of k plus 1 is k plus 1, okay, equals to k plus 1 equals to k plus 1 divided by 2, open brackets here. Our first term here is 1 over 6, so it's going to be 1 over 6 here, 1 over 6. What about our last term? It is k over 3 plus 1 over 6. It is what? It is k over 3 plus 1 over 6. K plus 1 over 6. This is our last term here. Okay, so from here now, when I'm done here, I must equate to 20 whole numbers, okay? 20 whole numbers and 1 over 6. Okay, so from here, I can simplify this k plus 1. This is k plus 1 over 2 into, now this is 2 over 6 when I add this one here, which gives me 1 over 3 plus, I can say, k plus 1 over 3 when I simplify over 3, then equals to the 20 whole numbers and 1 over 6. Hope we are still together. So from here, you can say I'm going to get k plus 1 squared, bracket squared, okay, and then 2 times 3, it is a 6, equals to 20 whole numbers and 1 over 6. So multiply by 6 both sides now. Let's check here. If I multiply by 6 to remove the denominator, I'm going to get k plus 1, bracket squared, is equal, I'm multiplying 6 times 20 whole numbers and 1 over 6. Now on the calculator, I want it, if I bring my calculator here, let's check. Calculator, come on, come on, come on. Calculator. Calculator. Yes. If I multiply the multiply the what? 20. That's 6 times what? Multiplying 6 times the 20 whole numbers. The 20 whole numbers and the 1 over 6. Guys, I think I'm writing it here. And 1 over 6. It gives me 121. Thank you. 21. So then equals to 121. 121 is a square number. It is what? It's a square number. So because of the k plus 1 square, I'm going to find now the square root. So this is 121. This is 121. So what do I do to get my k here? Because 121 is a square number, I just have to find the square root now to remove this square. I find square root on both sides. Okay. And so k plus 1 is plus or minus what? Plus or minus 11. But my k must be a natural number, so I take k equals negative 1 plus 11. I take the positive, because k must be a natural number. So therefore, my k, this is 11 here, my k should be 10. My k equals to 10. That's our answer here. Hope we are together, guys. My k equals to 10. Hope we are together. Yes, let us proceed. Oh yes. Now this question 3, November 2022. Question 3, November 2022 says that it is given that the general term of the quadratic number pattern is what? Tn. Okay. They gave us Tn equals to n squared plus bn plus 9. Okay. Tn equals to what? They're saying here Tn equals to n squared. What? Yeah, they're saying Tn equals to n squared plus bn plus 9. And the first term, what is 7? Now, the first term of the first difference is 7. I mean that our D1 is 7. Our D1 is what? Our D1 is what? Is 7. Okay, so they say show that B equals to 4. If I talk about D1, I think you know what I'm talking about, right, guys? We said that any quadratic number pattern is given by Tn, okay? Tn equals to an squared plus what? Plus bn plus bn plus bn plus c plus bn plus c. But then we know that to get this a, we say that we say 2a equals to d2. That's our second constant difference, okay? And then we also said that our 3a plus b equals to d1, okay? Equals to d1, which in this case is the same. Now from here, from our given expression here, our A with it is 1, because that is 1n squared, isn't it? So we can get our B by saying 3 times 1, okay, then plus B, which we are looking for, equals to D1, which is a 7, okay, which is 7. So what 7 minus 3? Our B becomes what? Our B becomes 4. So B equals to 4. That's our answer here. B equals to 4. Okay, then they say that the value of the 60th term for this pattern, our Tn, we can write it completely now as 1n squared. 1n squared, we know the B is 4, plus 4n, plus 4n, okay, then 9, okay, plus 9 here. So looking for the 60th term, looking for T60. T60 equals to 60 squared, okay, 60 squared, then plus 4 multiplied by 60, then plus 9. What do you get, calculator? What do we get here, calculator? Here I'm getting 3849. Get 8, then 9, okay? That's my T60. It is 3849. Okay, then next question here. They say determine the general term for the sequence of the first differences of the quadratic number pattern. Write your answer in the form TP equals to MP plus Q. Now the first difference is pattern, which is linear pattern or arithmetic. And for that matter, to make the things clear, let me just do something here for you like this. You know, if we like this, given by T1, okay, and then, okay, are we together? And then T3, okay, T3, and then T4. Let me go up to T5, and T5 here, okay, and T5 here. And now note that when you subtract T, the T2 minus T1, we get the first difference, and even T3 minus T2, and then T4 minus T3, and then T5 minus T4. So this one here also forms a pattern, and then T2, okay, and then T3, and then T4, okay, and so on, okay. Now the question is asking for this one here, the small t is okay. Now that Tn we're talking about here is given by Tn, okay, equals to A plus n minus 1 times D. Now in this particular case, our D is what comes here. That's the D which comes here now. Now in this given question for now, what? We know our first term, which is T1. That's the A which comes, that's what they gave us as 7. That's the 7 here talked about here. That's the 7 talked about in the question, okay? And then that's a 7 there. Now to get this D2 here, which is the D for this second pattern, we can use our 2A equals to D2. Okay, equals to D2. Now in the question here it is 1, so it's gonna be 2 times 1 equals to D2. So in that case our D is 2. So when I come here, I'm gonna say that our Tn equals to a, which a is the 7, then plus n minus 1, okay, plus n minus, that leaves now the 2 here. So guys, open brackets here. What do we get now? What do we get here? Open brackets. We are getting our Tn equals to 7 plus what? Plus 2n minus 2 plus 2n minus 2. Okay, so from here 7 minus 2 is 5. So our Tn is equal to 2n plus 5, equals 2n plus a 5 here. But the question said must give your answer in this form here. That form, which is what? This TP equals to MP plus Q. So I'm going to say here, my answer is going to be TP is equal, now my M is the what? Is the 2, equals to 2P, then plus 5. Now they use the 5 here, ne? Plus 5. Yeah, that's what they wanted here. And I hope we are together, guys. That's our answer there. Let us proceed here. Now here they say, which two consecutive terms in the quadratic number pattern have the first difference of 157? Have the first difference of 157. Now guys, I note this, please. Note this. You see here, take an example of this T4. T4 here. Now this T4 is given by what? By T5 minus this T4. I repeat, the T4 which you see is given by what? By T5 for the quadratic minus T4. Does that make sense to you? And so, because of this one being like this, the one I'm looking for, that is for, I'm gonna do like this. It means that I'm gonna say that the 157, okay, 157. I'm gonna use Tn. I'm gonna add to the Tn plus 1, okay, equals what? Tn plus 1 minus Tn for the okay. So because of that, I am gonna equate this Tn to this 157 to get my n. I hope you understand me. I'm gonna equate the Tn, okay, to what? To the given number, the given difference, which is 157, okay. Then I can get my n, because I know the Tn here is what? It is the 2n plus 5, equals to what? 2n plus 5, okay. Now if you subtract 157 minus 5, you get 152. Okay. Then 152 equals to 2n. If I divide by 2, I get my n as what? As 70 what? I divide by 2, I get my n as 76. Right, guys? 76. So now, because of this now, my n is 76, meaning that the question must be answered like this now. So the one I'm looking for is gonna be, because of this relation which I just showed you here, this one here, this one here, hope you won't get confused. What? 76 plus 1? 77. So in other words, to get that difference of 1 means I should subtract. Now the Tn plus 1 is going to be T77, because 76 plus 1 you get 77, and then the Tn is the T76. This is my answer here. This is my answer here. Hope we are together. Oh yeah, let us proceed. Let us proceed. Let us proceed. Let us proceed. This is question 2, 2022, May, June, 2.1. The first term of an arithmetic sequence is -1, and the seventh term is 35. Determine the common difference of the sequence. Now, arithmetic, we know I've got a common difference, né? And the nth term, the Tn for arithmetic, is given by what? By Tn equals the first term plus what? Plus n minus 1 times common difference, né? Okay, times d. Now, in this question, our first term a is -1. A is -1, and then they give us the seventh term, which is 35, né? Is 35, okay? So if we substitute here, we're gonna say our T7 equals 35. Sorry, our T7 equals to 35. Our T7 is 35. But what is our A? -1 plus n minus 1. Okay. But our n is 7, okay? 7. Okay, common difference. Okay, looking for this d here. But then we know the seventh term is 30 what? 35. Okay, so we're gonna say here equals to 35. Okay, equals to 35, and so we can get our d now. Okay, what do we do here? The -1 become positive, so we have 6d equals to 30 what? 36 equals 36 divided by 6. Our d becomes 6. Our d becomes 6. Okay, then next here they say determine the number of terms in the sequence if the last term of the sequence is for the n number of terms. Looking for the n number of terms. Okay, when the last term is what? Is 473. Now, being arithmetic again, to use Tn equals to our first term plus n minus 1 times d. N minus 1 times d. Now, in this case, 473, and our first term is what? Is -1, and then plus what? Plus n minus 1. Our common difference we know is the same here. It is the 6, which we just got now. So if you add 1 here, you get 4. Then divided by 16, divided by 6, sorry. to give us our n minus 1. To give us n minus 1. If we divide by 6 here, what do you get? Divide by 6, what do you get here? We're getting 70. We're getting 79. So 79 equals to n minus 1. And so, if you say we get our n as how many terms? As 80 terms. As 80 terms. So the answer is n equals to 80 terms. Now determine the sum of the first 40 terms in the sequence. Now the sum of the first 40 terms, we are going to use, we know the formula for the sum of terms of arithmetic. Sn equals to what? Anybody who remembers our Sn, our S for arithmetic equals to n over 2, okay? Equals to n divided by 2. Equals to n divided by 2. Open brackets here, 2a plus n minus 1 times d. Times d. So, talk about the first 40 terms now. You're going to look for S40. So our S40 is going to be 40 divided by 2. 40 divided by 2. Open brackets here, 2a. Now the a will give us net. Then we are talking about 40. So n is 40. So 40 minus 1. The common difference already we got 6. Ne? Okay. What do you get here? Calculators. Which answer do you get here? Calculator. Here I'm getting 0. 4640. 46. Then 40. That's our answer. Let us proceed. Next question here. They say that 75, okay, and then 53, and then, okay, this question here, they said that 75, okay, get some space here. It is what they say 75, and then 53, okay. So you have 75, and then also I have what? 53, and then 35. They say it's a quadratic pattern. Write down the 50th term, okay. Now to get our next term here, let us first know the differences here. Do you see what happens? Now if you subtract here 53 minus 75, what do you get? Calculators, what do you get in that case? Calculators, here I'm getting minus 22. I'm getting minus 22. The 35 minus 53, getting negative 18, okay. And then 21 minus 35, I'm getting negative 10, negative 14. Negative 14 here. Now being quadratic, I know that I must go ahead and get what? Get the common difference. Okay, this was 21 here. I must go ahead and get the second difference. So negative 18 minus 22, and also minus 14 minus 18, gives me positive 4 as well. So if I say negative 14 plus 4, what do I get here? I get negative 10. And then negative 10 plus 21, I get answer which they want here. Then I'll get T5, and that is 11, okay? 5, 11 here. What they said, determine the T5. So T5 is what? It is 11. Okay, then proceed. Determine the nth term of the number pattern. You're looking for the Tn now. So being quadratic, our Tn, we know our Tn equals to an squared. Our Tn equals to an squared equals to an squared plus bn plus c, whereby our a, we use this for here, we say that 2a equals to d2, okay? I think by now we know the d2 and the d1, eh? So here, my d2 is 4, so 2a equals to 4, meaning that a equals to what? A equals to 2, after dividing by 2, eh? After dividing by 2, my a equals to 2. My a equals to 2. Then also note that 3a plus b equals to d1. Our d1 here in this case is this one here, which is the negative 22, okay? So it was negative 22. And so I know the a, it is 2. So b equals to negative 22 minus what? Which gives us what? Which gives us negative 28. Ne? So is minus 28. The b is minus 28. Hope we are together. After getting the a and b, you can get our c by saying a plus b plus c. A plus b plus c should give us our T1, which is the 75 in this case, okay? Now the A, we know it is a 2. What about B? Minus 28, okay? This C here equals 75. Now in here, the 2 minus 28, that's minus 26, which will become positive. Now the 26 plus 75, that is 101. So 101. That's our C. Therefore, our Tn that we're looking for is by what? By A, which is 2n squared. Then our B is minus 28. Minus 28n. Then plus C, that's plus 101. Plus 101. So this is our general term. Okay. Let us proceed here. They say determine the maximum value of the following number pattern. Determine the what? The maximum value of the following number pattern. Now, if you check what we have here and compare, now in the question now, we're talking about minus 10, okay? And then next is what? Minus 21, minus 53, over what? Over 5, no? Over 5, but it's a minus, no? And then we have minus 7. We have minus 7, okay? Then we have negative 21 over 5. Negative 21 over 5, ne? Okay? Minus 21. Minus 21 over 5. Okay. Now guys, because it's a continuation of the question here, I can look for the relation between this term and the given term here. If I check here, because this one which was 53, you see it is 53 here, né? But now in the new term here, they make it negative 53 over 5. Meaning they're dividing by what? By negative 5. If I check the 35 here, they're dividing by what? They're dividing by negative 5 to get negative 7, right? And then the 21 divided by negative 5 also, that's what you get here. And then the 75 divided by negative 5, they get minus 15, which means there is a clue which I must use here. And so for that case, what do I know? Remember, this is quadratic. This is quadratic. Now the quadratic, we know it can have either a minimum value or a maximum value, depending on the coefficient of what? On the coefficient of the n squared here. Like this case, meaning that it has got what? Minimum value, because in that case the shape, we know it's going to be for the smiling face, né? The shape is going to be what? It's going to be different now. So they're dividing by negative 1 over 5, or they're multiplying by negative 1 over 5. It means that because now here I can get my minimum here for this Tn. Now my Tn, don't forget my Tn for the first one to here, né? So I can get its minimum. It's what? Its minimum value, né? Get its minimum value. And being quadratic, the minimum value I know is given by what? First of all, I get my n for the turning point, né? By using minus b over 2n. By using what? Minus b divided by 2n. Okay. So in this case, our b is the negative 28, né? So here I have negative 28. I have negative 28, okay? Negative 28. And then divided by 2a. And our a here is the positive 2. So 28 divided by 4. By 4 I get n as 7. So when n equals to 7, that's when this original quadratic, this one here, has minimum value, né? So that minimum for the original quadratic, okay, the Tn minimum for the original quadratic is given by what? Given by T of 7, okay? I'm putting now the 7, eh? By T of 7, okay? So when I put 7 in my expression for this Tn, so means my minimum value is going to be given by what? Let us substitute now. We're going to have 2 into 7 here, squared, okay? And then minus 28, 8 into 7, okay? And then plus 101, plus 101. Okay. What do you get? Calculators here. Calculators, you get what here? Now here with my calculator, I am getting a 3. I'm getting a 3 here. So the initial quadratic expression is a minimum of 3. So this new one here, because they are multiplying the original one by negative 1 over 5, né? Negative 1 over 5, which you see here, so that they get this new one here. Okay, it means that being a negative now, the n squared now is going to have a negative value, and in that case it qualifies to be called what? Maximum. So in other words, the maximum new quadratic term, okay, is going to be given by -1/5, okay, times the minimum for the old one, which is the 3, and so my final answer becomes what? Becomes -3/5. That's our answer here. Hope guys we are still together. If you have any questions, you can see me tomorrow after our lesson at Lost Ecology Purkwani, or you can join us online by clicking on the link below, or you can reach us on 0785 222041 for more explanations. If you don't have any of those, you can subscribe. However, let us proceed. Okay, to proceed now, here we have question 3, May, June 2022. They say consider the following geometric sequence. This one here. Calculate the 10th term of the sequence. Now the assigned is geometric, and so for that matter, we should be having a common ratio. Must be having a what? And the common ratio. The common ratio is given by what? You can say by T3 over T2. Where it's going to be 64. Okay. Divided by what? By 256. Divided by 256. What do you get? Calculators here. We get 1 over what? We get 1 over 4. That's our ratio. This step from here. Okay. So looking for the T10, our T10 would be given by what? By the first term. Okay. Then common ratio, power 10 minus, so that's power 9 here. So it becomes, there it is 1024. Okay, 1024. Then common ratio, we got 1 over 4. So times 1 over 4 here. Then to the 9. What do we get here? Calculators, what do you get as your answer? So here, I'm getting 1 over 256. 1 over 256. 1 over 256. Okay, next question here. They want to find now the summation p equals to 0 up to 8 of this expression here. Now this expression, which is in a sigma notation, as we see it here, we can see that if we expand it, so the saying calculate, check, we calculate the what? The summation from p equals to 0, okay, until what? Until 8 of 256. 6 into 4 to the power 1 minus p. 1 minus p. Okay. Now in here, if we put in p equals to 0, what do you get? What's 1 minus 0? 1. 4 power 1, 4. Then 4 times 2, 5, 6. What do you get? 4 times 2, 5, 6. Okay, this is giving us, okay, if I put p equals to 0, I'm getting 2, 5, 6. Okay, 2, 5, 6 multiplied by 4. Multiplied by 4 here. Okay. Then if I put in p equals to 1, 1 minus 0, 4 power 0 is 1, becomes 256, that's plus 256, okay. And then if I put p equals to 2, what's 1 minus 2? Negative 1. 4 power negative 1, that's 1 over 4, times 256, I get 64. I get 64. So if you check properly here, this given summation is actually what I have here in the original question. So I put up terms, and then I find out what the sum of those terms. How do you find number of terms? You say upper limit, that is 8, minus lower, which is 0, plus 1, which gives us what? Which gives us 9 terms. But I know that for given geometric, the Sn is by what? By the first term, open brackets, 1 minus common ratio to the power n. Okay. Then divide as common ratio. 1 minus common ratio. Okay, so here, now I'm going to say the sum of the first 9 terms, that's S9, equals to A. Now our A is this big value here, which is the 10, 24. 10, 24. 10, 24. Open brackets. 1 minus common ratio, which is, we got 1 over 4. 1 over 4. Then the power what? Power 9. Power 9 divided by 1 minus r. That's 1 minus 1 over 4. Okay. What do you get here? Calculators. What do you get? Substitute here. What do we get here? Here on my calculator, I'm getting 1365. 1365. 1, 3, 6, 5, comma what? Comma 33. Okay, that's my answer there. And then lastly, 3.2, they say the first 2 terms of the geometric sequence are these ones here. The first 2 terms of the geometric sequence, we have them here. That is this and this one. That means this is our T1 and this is our T2. Okay. They say that determine the value of T for which the sequence will converge. Now for this sequence to converge, what do we know from our theory? The common ratio must be what? Must be in -1 or less than 1. So it means we have to find a common ratio here. So for convergence, the common ratio, what? Between -1 and 1. So here, how do you find the common ratio? Our common ratio is given by T2 divided by T1. T2 divided by what? By T1. So in this case, my t2 is this one here, which is t cubed, okay, then plus 90 squared, plus 90 squared, and then plus 2070, okay, and then plus 27, plus what? Plus 27. Now divided by what? Divided by this other one. There is a 2 here, so divided by, now that 2, I'm going to put it in the denominator. That's divided by 2 into minus t squared minus 60 and then minus 9, okay? So what I'm going to do here now, if I take out the negative 1 in the denominator, what do I have? Now don't forget this common ratio must be between what? Must be, okay, but bigger than what? Bigger than the negative 1, okay? That's our theory. That's what we're looking for here. So we say bigger than negative 1. So because of the negative inside bracket, I'm going to take out a negative 2. Now that if I take out a negative 2 like this, it's going to be positive here and a positive here. I multiply by negative 2. When I do so, the inequality sign changes. So negative 2 times negative 1, I get positive 2. Now becomes greater than, okay? So here, I have t cubed. Okay? And then plus what? 90 squared. 90 squared plus 27t plus 27t, then plus 27 plus 27, then here multiplied by negative 2 becomes now greater than negative 2 here. Okay, so here now I'm dividing by now I'm remaining now with t squared, okay, plus 6t, then plus 9. So if I look at what I have here, I can factorize and then see what happens here. If you remember about our cubes, if you remember about our sum of 2 cubes, I have something like this. Now let's keep this one down for the denominator, t. Same as saying t, come on, same as saying t plus what? Plus 3, t plus 3. My stylus is disappointing. T plus 3. Okay, my goodness. T plus 3. Okay. Bracket what? Bracket squared. That's what I have for the denominator here. Now this other one here, if I expand it, if I look at it carefully, the same as saying t plus 3 cubed. T plus 3 cubed. Okay. In other words, I have 2 greater than t plus 3, t plus 3. Okay. Because it is cubed, I can say into another t plus 3 Okay, then I can say here, actually the same as the denominator, it will be more understandable to you. Okay, so I can say here t squared plus 6t, then plus 9 here, then divided by t squared plus 6t, then plus 9. So now this one, don't forget we have here greater than negative 2, don't forget that. So now this one can cancel, this one can cancel with this now. So I'm left with what? With the 2 greater than t plus 3, okay, greater than minus 2. So if I subtract 3 from both sides now, what do I get? 2 minus 3. 2 minus 3, it gives me negative what? Negative 1. So negative 1 greater than t, okay, then minus is minus 5, right? Like I can say that my t, that's our answer here, guys. Like I said, if you don't understand, please, tomorrow at the college after our lesson, you can come and see me, or you can call 041 to join our online classes, both for DBE and IEB, where you attend the 4. So thank you so much for watching. Catch you in our next video. Bye bye. Yes, hello. This is 2021 November, question 2. Let us proceed. It says, given the geometric series x plus 90 plus 81 and so on, calculate the value of x. So before they're saying it is geometric series, what should come into your mind should be the common what? The common ratio, right? The common ratio. And so, how do you find the common ratio? You can find the common ratio by using 2 divided by t1 or t3 divided by t2. So you can divide t2, okay, divide by t1 or t3 divided by what? By t2. And so if we do substitute now here, if we substitute, you can say that in this case, our t2 is 90. So we have 90 divided by x, which we are looking for, okay, equals to t3, which is 81, okay, 81, again divided by what? Divided by 90. So if I do cross multiply, I'm going to get 81x equals to 90 times 90 equals to 90 times 90. So now divide by 81, what do you get as 0? If I divide by 8 on both sides, I see my x here as 100. So x is 100 in this case. X is what? Is 100. That's our answer here. X is 100. After getting x as 100, we can proceed now. They say that show that the sum of the first n terms is Sn equals to 1000 into 1 minus power n. So how do we find sum to infinity? How do we find sum to infinity? Now that only is given by this. Remember, this is geometric, given by the first term. The first term, open brackets, 1 minus n, okay, divided by 1 minus what? 1 minus common ratio. So in this particular case, our a is the x, which is 100, okay, 100, open brackets here, 1 minus. Now our common ratio, because 90x is 100, we're going to have 0.9, okay. Our common ratio, the 90 divided by 100, you get what? 0.9. 0.9. Sum here, 0.9, then power what? Power n. Okay, power n, and then divided by 1 minus common ratio, that is 1 minus 0.9. So 1 minus 0.9 gives us 0.1. So if you divide by 0.1, we're going to get our Sn. Our Sn as what? As the 1000, okay, into 1 minus common ratio, which is 0.9, okay, 0.9 power n. Yeah, that is it, because the 0.1 gave us the 1000 here, and that's what they wanted here. Then they say, hence, all otherwise calculate the sum to infinity. Hence, all otherwise calculate the sum to infinity. If they say hence, all otherwise, you can use the hence part, or you can do it otherwise. Because it's very simple, I would use the formula. How do you find sum to infinity? Sum to first term a, the first term, divided by 1 minus common ratio. 1 minus common ratio, no matter what is our a? Our a is the x, which is the 100, okay, 100, divided by 1 minus common ratio. That common ratio we got 0.9. So from here, our final answer becomes 1000. Becomes 1000. Okay, that's our answer here. That was 2.3. All right. Hope guys we are still together. Let us proceed. Next question here. That is again 2021 November. Question 3. They say here that consider the quadratic number pattern -145, -122, -101. Write down the value of T4. Now T4 we mean the term number 4. We mean what? The term number 4. So being quadratic, what do we know? We can say here T2 minus T1, okay? T2 minus T1, then also T3 minus T2. So what is -122 minus 145? What do you get the calculator there? What do you get in the calculator? Here I'm getting, this is 23 here. And then -100 and minus 122. What do you get? Here I am getting 21. I'm getting 21, okay? And then being quadratic, we proceed. Now the 21, it gives us a -2, okay? -2. So now to get the T4 which we're looking for here, we are going to use the same -2, okay? So we're going to say 21 plus -2, what do you get? You get 19, okay? And then the 101 plus 19 to give us our T4. What do you get there? Calculator. -101 plus 19. What do you get here? I'm getting -82. So the T4, hope we are together. This is our answer here. -82 is our T4. Then they say here, show that the general term of this number pattern is given by Tn equals -n squared plus 26n minus 170. Now we said that here any given quadratic pattern is of the form Tn, okay, Tn equals to an squared, okay, plus bn plus c plus bn plus. If we know the pattern, like in this case, we have got the relation between the second difference and the a. What did we say that is that relation there? We said that the 2a equals to d2, 2a equals to d2. In this case, our d2 is a -2. So divided by 2, our a becomes -1. Our a becomes -1. And then the 3 here, that is 3a plus b. 3a plus b equals to d1. Yes. Okay, so now that I know the a as -1, we're going to say 3 times -1, then plus b equals to 23. So if I say 23 plus the 3, I get my b as 20 what? B as 26. Okay. So after getting a and b, what else do we know? That our a plus b plus c should give us T1. But our T1 here is a -145. Not this one here. -145. -145. So if I do substitute, I'm gonna say that my a is -1, right, guys? What about the b? It is 26. Okay. I'm looking for the c, and then I must equate to what? To -145. Okay. So if I simplify here, guys, c 26 and the -1, okay, I'm gonna get my c finally. My c becomes -17, -117, -117. And so therefore, our Tn is given by -n squared, or you can say -1n squared, then plus 26n, okay, plus 26n, plus 26n, and then minus 170 as required. Hope guys we are together. That is it there. Let us proceed. Then they say here that between which two terms of the quadratic number pattern will there be a difference of -121? between which number pattern will there be a difference of negative 121? Now guys, there is a relation between the first difference and whereby we say that we use small tn, okay? We use equals to what? Equals to, no, my stylus, come on. Okay, small tn equals to what? Let me use a different color maybe. Small tn equals to the tn plus 1 from the quadratic, that's capital T, tn plus 1, okay, and then minus what? Now our tn. So in other words, I can get my tn first by using the first differences. I'm gonna say that the tn is equal to a equals to a plus n minus 1 plus n minus 1 times d. Okay. Then in this particular case, my a is the 20 what? 23, isn't it? 23 here. 23. Then plus n minus 1. Now the common difference here is the second difference, which is negative 2. Which is negative what? Negative 2. My tn is going to be tn equals to negative 2n, okay, negative 2n. Now the positive 2 and 23 make it to be positive 25, okay. But then if should be equal to negative 121 as given in the question, so you can get the n in question. So equals negative 121, and so I'm gonna say till the 25, okay, plus 121 plus 121 should give me the 2n. So if I divide by 2, my n becomes 70 what? 73. 73, okay. Now that's it. What is n plus 1? My n plus 1 will be what? 74. Now meaning that the terms in the quadratic number pattern, they are gonna be between what? Between T74 and T73 and the T73. Because they said between which two terms, okay? So that's the answer here. So it's between T74 and the T73. Then they continue to say that 3.4, they say, what value must be added to each term? What value must be added to each term, okay, in the number pattern, so that the value of the maximum term in the new number pattern formed will be 1. Then that what value must be added to each term in the number pattern, so that the value maximum term in the new pattern formed will be positive 1. So here, let me first find my n for the maximum value here. Now, because our expression has got the coefficient of n squared as a negative, it means that the pattern has maximum, the same as saying maximum for the turning point, which I can get by using what? By using x equals to minus b over 2a, or I can call it n equals to minus b over 2, or I can differentiate. I can also differentiate. Okay, so what should I use here? Guys, what do you prefer? What should I use here? So if I may use the x equals to minus b over 2a, x equals minus b over 2a, okay, I'm going to have here my n, okay, equals to minus b over 2a. This is quadratic, guys. Now I'm gonna say negative. Look at our formula here for the original pattern. Our b here is 26, ne? So 26, okay. Our a is -1, so this is negative. Okay. What about our a? It's -1, so 2 times -1, it gives 13. Gives me what? 13. So in here, it means that my Tn or my T13, okay, would give me the maximum value. Will give me what? The maximum value, which I can find by substituting in the putting negative of 13 squared, okay, 13 squared plus 26 plus 6, that's our b, into 13. Then our c was minus 170. So what do you get as maximum here? So the maximum here, I take it from my calculator, it gives me what? Yeah, it gives me -1. It gives me -1. Now back to the question. They said that so here n is 13, ne? Don't forget n is 13 to give us this maximum value, ne? N is 13 to give us this what? Maximum value here. What is maximum value here? So this is the maximum value for this expression before the changes now. So now the question says that what must be done? What must be added? What must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1. Now it is -1. Okay, so now check here, we want to get 1. So what does it mean here? It means that if we want to get that now, check here. So from negative 1, if I want to get 1, what do I say? I say plus what? I say plus 2. I say plus 2, and then I'll get what? I get +1, which I need. So now this plus 2 here is what we are looking for. It must add a 2 to each term. Must add what? Must add a 2. Must add a +2 to each term. That's our answer here. That's our answer here. You must add a 2 to each term. You must add a 2 to each term. Okay. That is that question then. Hope it is clear. If not clear, this, you can see me tomorrow at the college, or you can inbox us on 0785 222041, or you can subscribe to get more such videos by attending with us online. Okay, now this November 2021, question 4, it says that consider the linear pattern 5, 7, 9, determine T51. Now, because the saying it is linear, what should come into our mind should be that we have a common what? A common difference. Yeah. So because we have a 5 and then a 7, okay, 5 and 7, and then 9, then 9 is 7 minus 5. What is 7 minus 5? What is 7 minus 5? Now 7 minus 5, it gives us a 2. And the 9 minus 7 also gives us 2 here. That's our common difference. So to get our Tn is given by Tn, do it here, maybe it's going to be better here. My stylus is giving me problems. I'm going to say here, the Tn, okay, is given by the first term, which is a, because it's linear, then plus n minus 1, plus n minus 1, plus n minus 1 times the n minus 1 times the common difference. So my common difference here, as you can see, means that if I'm looking for the T51, okay, I'm gonna say that my T51, which I'm looking for, T51 equals to A, but our A is 5, okay, 5, and then plus, now the n is 51, so I'm gonna say here 51 minus 1, 51 minus 1, then times the common difference, which is 2. So which answer do we get here? Calculators, what do you get here? What do you get here, calculator? What do you get here? Here I'm getting 105. I'm getting 105. So we have the same answer there. That's our T51, 105, okay? And then next question here. Calculate the sum of the first 51 times, Now we said in our introduction that the sum can be gotten in 2 ways, If you know last term, we said you can use Sn equals to n over 2 into the first term plus last term. Hope you still remember this, guys. Okay. Now if we're looking for S51, you're gonna say S51 is equal to 51, because 51 divided by 2 into our first term, which is a 5. Now the last term is our previous answer, which was 105, So that was T51. That was 51. So here, calculators, what do you get? Now answer here. If you say this expression, here I'm getting 2805. Getting 2805 to 2805. That's the sum of the first 51 terms. Okay. Next question. We're doing 4.3 now. Write down the expression of the summation from n equals to 1 up to 5,000 of 2n plus 3. Show only the first 3 terms and the last term of the expression. So you want the first two terms and the last term of the expression, okay? Now guys, note that the sigma notation up all we are adding. So in other words, the summation from n equals to 1 up to 5,000, okay, up to 5,000 of 2n plus 3. I'm going to keep on substituting from n equals to 1, n equals to 2, n equals to 3, and then the last one there. Okay, so when I put in n equals to 1, 2 times 1, that is 2. 2 plus 3, that is a 5. Okay. Then if I put in 2, 2 times 2, that is 4. 4 plus 3, that is a 7. Okay. If I put in n equals to 3, 2 times 3, that is 6. 6 plus 3, that is what? That is a 9. Okay. And then they said, show the first 3 terms and the last what? Last term. So here, I skip these other terms here, and they got the last what? The last term. Now the last term here, I'm going to substitute 5,000. So I'm going to set 2. I'm going to set 2. 5,000. 5,000, right guys? And then plus what? Then plus a 3. What do you get? Plus a 3. Calculator. What do you get here? Here I'm getting 10,003. I'm getting 10,003. Getting 10,003. Oh, that's what they wanted here. Now they say, hence all otherwise, calculate the summation. That's the first summation given here. Then plus summation from n equals to 1 up to 4,999 into negative 2n minus 1. So we are adding this other one here now. We are adding this other one here now. So we get some space here. So let me use a different color here. So what we are adding now is this one. That is summation from n equals to 1 again. Okay. From up to forward 4,999 of negative 2n minus what? Minus 1. Negative 2n minus 1. Negative 2n minus 1. So let us substitute in and see. So guys, if I put n equals to 1, what do I get here? Negative 2 times 1, that's negative 2. Negative 2 minus 1, I get negative 3. So negative 3 here. Okay. 2. Negative 2 times 2, that is negative 4. And negative 4 minus 1, that is negative 5. Okay, negative 5. So here I say plus negative 5. Plus negative what? Negative 5. Okay, then remember I'm summing up. Then next, if I put my n equals to 3, negative 2 times 3, that's negative 6. Negative 6 minus 1, that's negative 7. So negative 7 here. Okay. And then if I continue, n equals to 4. Negative 2 times 4, that is negative 8. Negative 8 minus 1, that's negative 9. Okay. And then now, If I skip some of the terms here, and I continue and I continue and I continue, okay, if I put in if I put in the last term, which is 500, what do I get? Let me check here with the calculator. Remember, it is 2n plus 3, okay? If we put in 500, what do we get? If I put in 500, what do I get here? Let's check it out. If I put 500, let's find out here. Don't forget it's negative 2, okay, into 500, the last term, I mean 499, not 500. It is here 499, 499, 4999, okay. Then they said minus 1, so minus 1 here. You see we get negative 9,999, okay. That's for the last term, It's negative 9 4 times. We have negative 9 times. It's negative 9 here. Negative 9. Check for negative 9. Check for. Are we together? Negative 9. 4 times. Okay. Another one here. Then if I put in now a less number, let's see what we get here. 4998. If we put now 4998, what do we get? Negative 9997. Negative 997, okay. So here we have negative 99997. Okay. Then if I put in the other one, let's check just one more time. If I put in let's say 49997, okay, let's find out. 4997. Okay, here it gives me negative 995. Negative 995, negative 999 and what? And the 5, Okay, now if I come back this other one here, remember I went until 5,000, Let me go backwards a little bit just by 1 digit. Okay, that's 2n plus 3. If I say maybe 49999, okay, like this. Now here, if I say 2, open brackets, and I put 4,999, okay, then they said plus 3. What do you get here? You see I'm getting positive at 10,001, 10,001, okay. So 10,001 is the one which comes before this, okay, which comes before. Let me say 10,001 is here, okay. 10,001 is just for the what? My sliders now, come on. Yes, 10,001. Okay, 10,000. 10,000. Don't forget our common difference is 2, 10,001. Now again, before that now, before the 10,001, if you say minus 2, what do you get now? You get positive what? Positive, here minus 2, get positive what? 9 chef 4. Get positive 9 and a 9. And now they said we are adding, don't forget we are adding here. Now if we are adding, let's add and see. If we are adding, you guys can see that This 5 and negative 5 is going to cancel. Then the 7 and negative 7 will cancel. Then the 9, negative 9 will cancel. So they're going to keep on cancelling. Even this other one, which is the 999, this one here, the quadro 9. So meaning this one they're going to cancel with the those ones which are before here. And so in other words, my answer, I'm remaining with what now? With this negative 3, right? Negative 3. Okay. Then plus what? Plus 1, okay. Plus 10,001. Plus 10,001. Okay. And then plus 10,003. Plus 10. Plus 10,003. So now my final answer here is gonna be what? It's gonna be 20,001. It's gonna be 20,001. 20,001. Yeah, that is it, guys. Yeah. All right. Let us proceed. Let us proceed. Yeah, so once again, you're welcome. This is Patrick Kamala, tutor educator, mathematics and physical sciences, grades 8 to 12. Now, in this question 2, from May, June 2021, is what we are doing right now. It says, consider the quadratic sequence 72, 100, 120, 132. Determine Tn, that's the general term of this sequence. Okay, so let us see what to do here. Now, if they give us the terms, okay, we know that any given quadratic key has got an squared plus bn plus c, and so for this case now, and so for this matter, our Tn, okay, we have got 72, and then 100, okay, and then what? And then we have 120. We have 20. What do we have now? We have 132. 132, okay. So now with this information, you can find the Tn, okay. But first of all, we need to subtract T and C until you get the common difference. The second constant difference. Okay, so here, now the 100 minus 78, okay, guys. And then 120 minus 100, get 20. And then 132 minus 120, we get 12. We get 12 here. If we proceed, the 20 minus 28, we get negative 8. And then 12 minus 20, also negative 8. And so we have, because we have the same second constant difference, we know that any given quadratic, the Tn is given by what? By an squared, okay, plus bn plus c, an squared plus bn plus c plus bn plus c plus bn plus c. But we know that to get our a, what do we use? We said we can use 2a. 2a equals to d2. 2a equals to d2. Now our d2 here is a negative 8, right guys? Negative 8. So divided by 2, which gives us our a as negative 4. After getting the a, then now we can go ahead and get our b by using what? By using 3a plus b. By using 3a plus b. 3a plus b equals to d1. Now our d1 here is 28. 28, okay. And then, but we know the a is negative 4. So 3 times negative 4. 3 times negative 4 plus b to give us 28. To give us 28. So for that matter, then negative 12 become positive, making our b to be 40. Is after getting the b, then we can get our c. We can get our c by doing what? By using a squared, another a plus b plus c, a plus b, a plus b plus c equals to t1. Equals to t1. Our 20 is the 72. So we're going to substitute. We know the a is negative 4. So negative 4. Negative 4. What about our b? B is 40. Our b is 40. So negative 4 plus 40. Negative 4 plus 40. And then c equals to 70. Plus c equals to 72. Equals to 72. And so, if I look for c here, I can see that the 40 will become minus, the negative will become positive. And by my calculator here, when I get my c as 36. My C is 36. Okay. After getting A, B, and C, now you can get our Tn. So our Tn equals to our A, that's minus 4n squared, minus 4, and then plus what? Plus 40n, okay, plus 40n, plus 40n, plus 40n, and then our C is 36 plus 36. That's our answer here. And I hope we are right. That's our Tn, which is equal to negative 4n squared, negative 4n squared, okay, negative 4n squared. That's our Tn, negative 4n squared plus 40n, then plus 36. Okay, let us proceed. Next question here. They say that a term in the quadratic sequence 72, 100, 120, 132 is the term of the sequence of the first differences. Determine the position of this term in the quadratic sequence. They're saying that a term in this quadratic sequence is equal, okay, meaning 212 of what? Of the first differences. Okay, so determine the position of this term in the quadratic sequence. Looking for the n for this position in the quadratic sequence. Looking for the n for this term. Okay. Now from the beginning we said that the first differences, they also form a pattern, okay, which is linear. So like in this case, we can get our pattern, okay? We can get our pattern. Let us use it now. Now as you see here, now what are we talking about here? Guys, these terms here, these ones, these terms, the 28, the 20, and the 12, we call them the first differences, and they form a pattern which we call the small tn. So our small tn, okay, our small tn equals to the first term, that is n times d, plus what? Plus n minus 1 times d. Okay, but then in this case, our a is the 28. Our a is what? Is the 28. Okay, our a is 28. Our d is the negative 8. Our d is what? Negative 8. And so because they said that's the T12 for this term, so our T12 now, our T12, we're gonna get here our T12 is 28. We get 28, okay, and then 28, and then what? Plus 12 minus 1 plus 12 minus 1 multiplied by negative 8, okay, by negative 8. So here, what we get, calculators, the 28, now so become positive here, it's going to be now 28, right? And then this is 11 times negative 8 divided by 8. negative 88. So 28 minus 88, it gives us negative 60, meaning that that is negative 60. Now this term, we want to know its position in the what? In the quadratic pattern. Okay, so what we're gonna do here, because we have our Tn, I'm gonna equate the negative 60 to the Tn for the general quadratic, right guys? So that I can be in position to find my n, which is the position. So I'm gonna say here, negative 60 equals to Tn. But what's our Tn? It is here. We got negative 4n squared plus 40n, negative 4, okay? Negative 4n squared plus 40n plus 36 plus 40n plus what? Plus 36. Okay, so from here, we can get our n by solving normally. So 4n squared after crossing cosine become positive 4n squared, okay? Then minus 40n minus 40n minus 40n, and then the negative 60 minus 36 become negative 96. Negative 96 equals to 0. Equals to 0. Okay, so from here now, divide by 4 everywhere. I have n squared here. Minus what? Minus 10n. Minus 10n. And then, now 96 divided by 4. I get 20 what? I get 24. 24 equals to 0. I think here I can get factors, right guys? Get me the factors, two numbers, multiply, get negative 10. So we have n minus 12. Okay. Then also we have what? N plus 2. N minus 12 into n plus 2 into n plus 2 into n plus 2 equals to 0. So here my n, which must be a natural number, is going to be equal to what? Equals to 12, right guys? I can't take the negative, né? So my n will be what? It's 12. My n is 12. The answer, it is in the 12th position. So the answer is n equals to 12, meaning it is the 12th position, whereby that number, it happens to be the 2 in the sequence of the first differences. Let us proceed. Next question. What does it say here now? They say here that determine the maximum value of the quadratic sequence. After getting our Tn, and this is quadratic, find the maximum, okay? You can find what? The maximum, because we know that the quadratic, which has got a negative n squared coefficient, gives us a maximum, because the shape would be like this, né? Where we get a maximum, right guys? Maximum. Our Tn, don't forget, our Tn which we got, it's negative 4n squared, negative 4n squared, negative 4n squared, and then what? Plus 40n, okay? plus 40n. Right, again, constant, we go to what? The constant was 36, ne? So plus 36. Now in the calculus, to get our maximum, or the turning point in this case, we differentiate and equate to 0. So if I differentiate the t with respect to n, I'm gonna get what now? I'm gonna get negative 8n plus 40. I get negative 8n plus 40 equals to 0, because at turning point or at maximum value, the gradient is 0. So from here now, if I say that my n equals to 40 divided by negative 8, I get what? Negative 40 over 8. What do I get? I get my n as 5. Ne? So because I'm looking for the maximum now, after getting this 5, okay, after getting this 5 here, I come and find my maximum by finding t5. So tn maximum equals to t5 equals to t5 equals to t5, ne? Okay, equals to t5. Let us substitute now. When we do so, we are gonna say here negative 4. Negative. My stylus, guys, sorry about that. Negative 4. Negative 4. Okay. Negative 4. But the n is 5, ne? Then 5 squared. 5 squared. And then plus 40. Plus 40. Plus times 5. Plus 40 times 5. It gives me what? Then plus 36, ne? Don't forget. Plus 36. Do you get calculators? Now here, I'm getting what here? With my calculator, I'm getting calculators. What do you get? What do you get here? So I'm getting 136. I'm getting 136. So the maximum value is what? 136. I'm getting 136. Alright guys, that's our answer here. Let us proceed. Now they say here that determine. So here our answer is 36, 136. Don't forget. Here our maximum is what? 136. 136. Okay. Now they say that determine the maximum value of the next sequence. What that is? Negative 23, 5, 25, and 37. Now, guys, I want us to go slow here. So they're giving us 1 mark, ne? Meaning not too much work to be done here. Now, you see here, I was having the 72, 100, 120. Put them here. Was having what? Was having the 72. Okay, check. I was having at first. This was 72. The 72, right? Followed by what? By 100. Then followed by 120. Nice stylus here. 72 followed by 100, okay, and then 120. Stylus is killing me. Oh. Alright, let me see this, guys. Please follow me. Okay, so now from the 100, you see they have 5, which means they're subtracting 95. Do you hear me? They have 25. 120 minus 95, you get 25. Then 132 minus 95, you get 30. So 72 minus 95 also get negative 23. Meaning that our maximum here is going to be this one, the 136, also minus what? Minus 95. Okay, so what do you get now? Calculators. What is 136 minus 95? What do we get here? Here I'm getting 41. Here I'm getting 41. Okay, that's my answer here. I'm getting 41. Okay, next question here. That is question 2.2. Consider the sequence negative 11, 2 sine 3x, and 15. They say here that determine the value of x in the interval 0 to 90 for which the sequence will be arithmetic. What do you know about arithmetic? With the arithmetic, we have a constant difference. Okay, and so for that matter, what do we do here? I'm gonna say, so my here is negative 11, t is 2x, and t3 is 15. So being arithmetic, what do we know? We know that, how do we find the constant difference? By saying t what? T2 minus t1, okay? I'm gonna say here that t2, okay? Here is my stylus, sorry. T2 minus T1, 2 minus T1 equals to T3, and no. Okay, just like my work. If I use black color here, so my T2 is 2 sine what? It is 2 x 2 sine 3x, then minus 11, 2 sine 3x, 2 sine 3x, okay, 2 sine 3x, that makes it positive 11.